Namaskar everyone. My dear students, I welcome you all to this GATE through question series and today we will be discussing fluid mechanics. So in today's lecture, first of all, the mode of teaching or whatever discussion that I am going to do in today's lecture is going to be in English. Let me clarify that because so that students from all the parts of the country, basically from southern India, they should also get to understand that what sir is trying to convey. So most of all the discussions are going to be in English. So my dear students, first of all, just tell me in the comment box. I'm equally excited as you people are. I know that you guys are really excited about the session. I'm equally excited. I have planned some beautiful set of numericals for you guys. We are going to start, but before starting anything, just tell me in the comment box, am I audible and visible to you guys? Is everything fine? हरी झंडी दे दो भाई, शुरू करते हैं. हरी झंडी दे दो, शुरू करते हैं. Excellent. Yes, everything is fine. Everything is fine. Wonderful. So my dear students, few things before starting, let me tell you guys. The first thing is that today's session is going to be a long session. So approximately I am going to take 3 to 3.5 hours because I wanted to discuss a buffet of questions with you guys which might be very probable for GATE 2023. So the questions that I am going to bring on board today are mostly GATE relevant questions. I have tried to avoid conventional questions, but still I have tried my level best that I should match up with the quality of the GATE examination. Apart from this, as the session is going to be long, it is my humble request to you guys that you please have pen, paper with you and solve all the numericals which are coming on board with me. Okay, so if you are confident, and see the questions are going to come on the board, if you are confident that's okay, I don't need the support of sir, or I don't need the formulas that are going to be given by the sir, and I can carry forward by myself. If you are confident enough, then you keep on solving without looking at the board. Okay, so I am going to give you sufficient amount of time for all the questions so that you can know about your preparation, that at what level of preparation you guys are. But before starting the session, one very important point is, similar kind of session I have already taken on Made Easy YouTube channel. I have already taken similar kind of session, that is GTQ 2021, and I have taken GTQ 2022. So previous 2 years GTQ, some awesome set of questions are already there on YouTube of fluid mechanics. Some awesome set of questions are already there on YouTube. So GTQ 2021, if I remember correctly, approximately I took this session for 2 hours, and GTQ 2022 approximately I think I took the session for 3.5 hours. So first thing is that all the questions which were discussed in these two GTQs, I have tried my best that I should not repeat the same questions in this year's GTQ. Okay, but this doesn't mean that whatever things I discussed in GTQ 2021 and GTQ 2022 are not relevant. In fact, several very important problems are already been discussed. But today we are going to avoid those problems because they are already on YouTube and you can watch. Okay, so the link of these two GTQs, these two GTQs after today's session, I am going to put down in the comment section so that the students who doesn't know can first of all look at GTQ of 2021 and 2022, and then he can carry forward his journey for today's session. Okay, chalo. So are you guys ready? Are you guys ready? Just tell me in the comment box, are you guys ready? Should we start? Should we start? Yes, yes, yes. Wonderful. Oh my God. Oh my God. I'm really happy. So many students are there. But my dear students, I'm informing you, you should attend the complete session. Then only it will be helpful to you guys. Okay? So we are starting. See, first 20 minutes of today's lecture, approximately 20 minutes of today's lecture, I have planned some questions for you guys so that we are able to revise the complete subject in a holistic way, in just a theoretical manner. Okay, so first 20 minutes easy questions are going to be there. In fact, very easy questions are going to be there. Just the statement type of questions are going to be there. Okay, so we are starting. Then after that, some beautiful problems are going to come. So this is the first question that is there on your, this is the first question that is there. Please read the question carefully. Read the question carefully. Which of the following statements are true? So you have to tell that out of all these statements, which are the statements which are true. Let us read first statement. With increase in temperature, the dynamic viscosity of liquid increases. Is it correct statement or wrong? This is a wrong statement. So this is false. This is false. Why this statement is false? Because everybody knows that with increase in temperature, the dynamic viscosity of liquids is going to decrease because the bonds are going to break. So when the bonds are going to break, the viscosity is going to decrease with increase in temperature. And you know the main reason of viscosity in case of liquids is the molecular bond or cohesion. Next statement. With increase in temperature, the kinematic viscosity of gases. See, if you are talking about gases, the dynamic viscosity as well as the kinematic viscosity, they increase. So this statement is true statement. This is the true statement. Okay. And already in the classroom, if you are my classroom student, you guys might be knowing, I already did the derivation of this in the classroom, that kinematic viscosity of a gas is T raised to the power 3 by 2. And dynamic from Sutherland's equation, do you guys remember? Come on. Tell me in the comment box whether it is true or false. So dynamic viscosity of gas varies as T raised to the power 1 by 2. So the kinematic viscosity of a gas increases at a faster rate. See, I am going to discuss each and every statement. I can just tell you the answers, but I want you guys to revise with me. That is also one of the most important part of this GTQ series. With increase in temperature, the surface tension decreases. Yes, this statement also appears to be true. Why this statement is true? Because surface tension, again, it is dependent on cohesive bonds or intermolecular forces of attraction. So with increase in temperature, the bonds are going to break. Hence the surface tension is going to decrease. Higher the volatility, more is the vapor pressure. Yes, correct. Higher volatile fluids such as petrol, benzene, their volatility means easiness of forming vapors. Easiness of forming vapors. So if easiness of forming vapors, and hence you know the vapor, yes, more higher the volatility, higher is the vapor pressure. So which of the following? So again, this is a true statement. This is a true statement. So on this board, he is asking which of the following statements are true. So B, C and D. B, C and D are true statements. Okay. Chalo, let us move forward. Tell me again, the question remains the same. You have to tell me which of the following statements are true. This time for Bingham plastic fluids. Everybody knows that for Bingham plastic fluid is saying the value of N is 1. Yes, because it is a linear relation. Na? It is a linear relation. And B is not equal to 0. Yes, there is going to be some yield stress in case of Bingham plastic fluids. Na? How is the graph for Bingham plastic fluids? The graph for Bingham plastic fluids is something like this. So the graph is not going to start from origin. Next, shear thinning fluids. So again this statement is true. This statement is true, my dear students. Next, for shear thinning fluids. Now what is shear thinning fluids? dilatant is known as shear thickening fluids, and pseudoplastic is known as shear thinning fluids. Now for shear thinning fluids, see here the problem lies here. N is less than 1. So the graph will be of decreasing slope, na? The graph will be something like this for shear thinning fluids. So this statement is false. So this statement is false, my dear students. Come on, tell me in the comment box. Be active. Cavitation is a high pressure phenomena. Everybody knows that cavitation is going to take place when the pressure falls below the saturated vapor pressure. So cavitation is not a high pressure phenomena, my dear students. It is a low pressure phenomena. So again this statement is false. Next important thing. For a viscous flow, the shear stress distribution is always one order less than the velocity distribution. Everybody knows this, that tau is equal to mu into du by dy. So whatever is the velocity distribution, देखिए हम स्टार्टिंग में आसान क्वेश्चंस इसलिए डिस्कस कर रहे हैं, स्टेटमेंट टाइप इसलिए डिस्कस कर रहे हैं ताकि थोड़ा बॉडी गर्म हो जाए भाई। थोड़ा सा बॉडी मतलब वो आ जाए, एक जो इनर्शिया होता है, हम कंफर्ट जोन से बाहर आ जाए और एक मोमेंटम गेन कर लें बिफोर द डिफिकल्ट प्रॉब्लम्स। सो जो भी वट एवर इज गोइंग टू बी द वेलोसिटी डिस्ट्रीब्यूशन, द shear distribution is going to be one order less than that. So it is written the shear stress distribution is always one order less than the velocity distribution. So this statement is true. So out of these, E and H are the true statements. Wonderful. Let us move on to the next problem. Still a lot of more statements are there. Come on, read. With increase in pressure, the compressibility increases. See, already told to you in the classroom that with increase in pressure, the bulk modulus of elasticity increases, but the compressibility decreases. Because when you are going to increase the pressure, what is going to happen? The molecules are going to come closer to each other and it will become difficult to compress them further. So this statement appears to be false. Wonderful. Next, the pressure on the convex side. Already told in the classroom, this is going to be concave side of the curved interface and this is convex side of the curved interface. And everybody knows, for example, if this is 1 and this is 2, in our classroom we have beautifully derived. I think if you are my student, no one can forget the classroom of Young's Laplace equation. No one can forget that. No one can forget that. So convex side and concave side. So he is saying, and everybody knows that the pressure is greater on the concave side in comparison to convex side. What is the equation? Let us revise. Pi minus Po is equal to sigma times 1 by R1 plus 1 by R2. So this is the equation, that is the Young's Laplace equation for a single interface system. So pressure on the convex side of the curved interface is always greater than the concave side. This is wrong. This statement is again wrong. Last one. Compressibility is the reciprocal of bulk. Now this is correct, because everybody knows mathematically compressibility beta is defined as the reciprocal of bulk modulus of elasticity. So this statement is true. So in all these statements, only the K statement is right. Oh, I'm happy. A lot of you are giving the correct answer. Himanshu, Ankit, Archit, Gaurav, Praveen, Anjani, Ayush, Shailesh. बहुत शानदार. Excellent, my dear students. Chalo. Read this problem and give me the answer in 2 minutes. Timer is there on the board. Read this question and tell me the answer in 2 minutes. Come on, come on, come on guys, come on, come on, come on guys. Read this problem and give me the answer in 2 minutes. The timer is going on the board. I don't think you will be requiring 2 minutes for this. I don't think you will be requiring 2 minutes for this. I am giving you only 1 minute. धोखा किया है मान रहा हूं. पहले 2 मिनट बोला, अभी 1 मिनट बोल रहा हूं. Because I don't think आपको 2 minutes लगेंगे इसके अंदर. Yes, very good. A lot of you are giving the correct answer. Ajay, Biprajit, Sanket, Sai Narayan, Sachin, Pooja, Abhinav. बहुत बहुत बढ़िया बच्चों, बहुत बहुत बढ़िया. चलो इसको रीसेट कर देते हैं, इसको अंदर डालते हैं. इधर देखो, बच्चा बच्चा जानता है, आपको पता है फुल्ली डेवलप्ड आपको पढ़ाया गया है कक्षा के अंदर, आपको पढ़ाया गया है कक्षा के अंदर. सो यू नो this zone, this is known as fully developed zone, and you know in the fully developed zone the velocity profile becomes constant. The velocity profile becomes constant, whereas in the developing zone the boundary layer is going to increase and going to reach up to the center line. My dear students, the beauty that you should know here is that the wall shear stress is going to decrease in the developing zone. So this is the developing zone. This is the developing zone. You know, the wall shear stress is going to decrease, but once it becomes fully developed, the wall shear stress is going to become constant. Of course, the reason being tau is equal to mu into du by dy. So once the velocity profile becomes constant or it becomes fully developed, so this is the variation of the wall shear stress. So my dear students, who is going to have the maximum wall shear stress? A is going to have maximum wall shear stress. So A is the correct answer. A is the correct answer. Okay. Let me make you revise a few things. This is known as entry length. This is known as what? Entry length. And I hope you guys know that entry length for laminar is always greater than the entry length for turbulent flow. Is always greater than the entry length for turbulent flow. And you know this was given by these are the values just for the sake of your reference. These are not going to be asked in GATE paper, but who knows? Who knows? Who knows? But still I have given you the values of entry length of laminar and entry length of turbulent. See, these two values you can jot down in your register, because this you will not find in the notes. So that's why I have written on the board. That's why I have written on the board. So you are going to learn a lot of new things. You can note these values down in your register, main register. Okay. So answer is A, Agra. Answer to this question is A, Agra, because tau A is going to have the maximum shear. Chalo, let us move on to the next problem. Again 1 minute of time. Again 1 minute of time. Time starts now. Time starts now. Again 1 minute of time. Please see, my dear students, this is a multiple select question. This is a multiple select question, my dear students. Come on, come on, come on, come on, come on. देखो भाई, उम्मीदें बहुत हैं, कर दो इसको जल्दी से. मुझे नहीं लगता इसमें भी आपको 1 मिनट लगना चाहिए. मैं तो कह रहा हूं 30 सेकेंड्स में जवाब दो. Very good. Gaurav, Pooja, Meena, Shivam Chaudhary, Sameer. अरे गजब. Almost everyone is giving the correct answer. तो टाइमर को स्टॉप कर देते हैं, रीसेट करते हैं. आओ देखो, identify the configuration which will show boundary layer separation if the flow direction is from left to right. Flow direction is from left to right. तो वो पूछ रहा है कि कौन से कॉन्फ़िगरेशन में बाउंड्री लेयर सेपरेशन का चांस है. अभी मुझे ये बताओ, बाउंड्री लेयर सेपरेशन, द मेन रीजन ऑफ बाउंड्री लेयर सेपरेशन इज द एडवर्स pressure gradient, yes or no? And if you are talking about adverse pressure gradient, then del P by del X should be adverse pressure gradient is del P by del X positive, and that is going to happen when you increase the area of the flow. So as you can see here, this is converging. So this is not adverse pressure gradients, these are favorable. This is favorable section. This is favorable section. Here you can see the area is constant. Area is maintained to be constant. But here the area is increasing. And if area is increasing, the pressure gradients in this is going to be adverse. So the chances of boundary layer separation are there. Here everybody knows eddy formations are going to be there. There is abrupt change in area is there. So therefore here also the chances of boundary layer separation are there. So which two options are correct might be, as it is a multiple select question, so C and D are the correct option. C and D are the correct option. Excellent. I'm very happy. I'm really very happy. A lot of you are giving the correct answers. I'm really very happy. Let us move on to the next problem. Oh, yes. Chalo, batao. 1 minute for you guys. Read the question carefully and tell me the answer in 1 minute. Come on, guys. Come on, guys. Yes. Really, I'm very happy. Mohit, Sachin, Anjani Sharan, Rahul Ranjan, Sagar Kapadia, Gaurav Rai. क्या बात है गौरव. I think you are correct गौरव. अभिनव, अभ्युदय. ये क्वालिटी स्टडी कैसा नाम होता जी? क्वालिटी स्टडी कैसा नाम होता? लास्ट 19 सेकेंड्स. आई थिंक ये भी 1 मिनट का सवाल है. See, again in the problem he is asking you which of the following statements are true for the streamline in a steady incompressible flow. Streamline can intersect with itself or two streamlines can intersect with itself. Oh my god, this statement is false. 101% this statement is false, because streamlines can never intersect with itself and can neither intersect with each other. Wonderful. Next, yes, this is the equation of streamline. So this statement is true. The distance between streamline is directly proportional to the velocity of the flow. झोल है इसके अंदर, झोल है. क्या झोल है? इनवर्सली प्रोपोर्शनल होता है. सो ये फॉल्स स्टेटमेंट है. आप देखो ना, if you remember the classroom, distance between streamline is inversely proportional to velocity of the flow. So higher the velocity, streamlines will come closer to each other. So the distance is going to decrease. So for example, if the streamlines are coming closer to each other, the distance is decreasing, this represents that the velocity of the flow is increasing. So again, this statement is false. Path line represents streamline. Now see, there is a thing. If you read the problem carefully, he has written that the flow is a steady flow. He has clearly mentioned that the flow is a steady flow. And I can see a lot of students committing mistake. Here. This statement is true, my dear students. This is true. This is not a false statement. Why this statement is true? Everybody knows that for steady flow, the path of the particle, its path line is itself the streamline. You read in the classroom na, that for a steady flow, streamline, streak line and path line are going to coincide. They will become one. Do you remember that? So if it is a steady flow, everybody knows that path line is going to represent the streamline for a steady flow. So this statement is true. A lot of you have committed mistake here. So there was, देखो मेरा trick काम कर गया, मैं happy हूँ. But देखिए, गलती कीजिए यहाँ करिए, घर पे करिए बैठकर, एग्जाम हॉल में मत करिएगा. ठीक है, आओ अगला देखते हैं. Stream function is constant along the streamline. This is true again. The difference between stream function give discharge per unit width. So yes, this is again correct, because you know the volume flow rate can be written as psi 2 minus psi 1. Mod of psi 2 minus psi 1. So yes, it represents discharge per unit width. So this statement is also true. So which of the following is true, he is asking. So our answer is B, D, E and F. B, D, E and F. B, D, E and F. B, D, E and F is the correct answer. Wonderful, excellent. Let's move on to the next problem, my dear students. Be highly aware. This time he is asking which one is false. Which one is false? Chalo, chalo, chalo. Again, दिया आपको 1 minute दिया. 1 minute दिया. Come on, come on, come on. Tell me the answer. Which of the following statement is false? मेरे ख्याल से आपको 30 सेकेंड से ज्यादा टाइम चाहिए ही नहीं इसके अंदर. I think that you don't need more than 30 seconds for this particular problem. But still, अरे वाह, almost every one of you is giving the correct answer. I'm really happy. Shivani, Abhinav, Nikita. Oh my God, it's moving too fast. It has become very difficult for me to read. चलो इसको reset कर देते हैं. आ जाओ इधर देखो बच्चों. Consider the below statements. Which of the following statement is false? If the velocity potential function exists, मतलब वो कह रहा है जी phi क्या करता है, exist करता है. भैया phi can only exist when the flow is irrotational. So this statement is true. This statement is true. Vorticity is half of the rotation. This statement is false. Why this statement is false? Because everybody knows that vorticity is twice the rotation, not half of the rotation. Not half of the rotation. Okay. Next, for an incompressible flow, the divergence of vector v is 0. So this statement is again true. This statement is again true because yes, the divergence is 0. For incompressible flow, the curl of vector v is 0. The curl of vector v is 0. Wonderful. So this statement is false. Why this statement is false? Because you know the curl of vector v is 0 for irrotational flow. This is the condition for irrotational flow. Now let us come back. Which of the following statement is false? So what are the statements which are false? B is false and D is false. B is false and D is false. So B and D is going to be our answer. Chalo, let us move forward. Oh, there are, oh my God, so many more number of statements are there. Chalo, let us read fast. Friction factor for laminar flow is a function of Reynolds number only. See, he is not talking about turbulent flow, he is talking about laminar flow. Laminar flow, okay? So everybody knows that friction factor for laminar flow is a function of Reynolds number only, because for laminar flow this is 64 by Reynolds number. So this statement is true. This statement is true. Next, work done in stretching any liquid surface is directly proportional to the increase in surface area. Yes, this is again true. This is again true, because everybody knows that work done in stretching any surface will be sigma times the change in surface area. Okay. Next, the center of pressure. The center of pressure. What is center of pressure? Center of pressure is actually the point where the hydrostatic force is going to apply. The resultant of the hydrostatic force is going to apply over a plane surface can never lie above the center of gravity. It is true. It is true again. Yes, it cannot lie above center of gravity, because either the center of pressure will coincide with center of gravity in case of horizontal plane surfaces, or it will lie below the center of gravity, because everybody knows now H can either be equal to x bar, where x bar is the vertical distance of CG from the free surface, or H can either be greater than x bar. But H being less than x bar, this is impossible. This is impossible. Are you guys getting my point? Yes. Next, path lines can intersect with itself. Of course. See, path line represents the Lagrangian method of the fluid flow. It is a technique to represent the Lagrangian method of the fluid flow. So this statement is again true, because path line is for different the location of a single fluid particle at different instance of time, my dear students. So therefore definitely the path lines can intersect with itself, of course. So all of them are correct, no one is wrong. No one is wrong. भाई कोई गलती नहीं है, सब के सब सही है. आओ अगला. Which of the following statement are correct? अब थोड़ा फास्ट मूव करेंगे, अभी थोड़ा गर्मी आ गया शरीर में, अब थोड़ा फास्ट मूव करेंगे, ठीक है, ताकि हम मुश्किल क्वेश्चंस की तरफ ज्यादा टाइम स्पेंड कर सकें. Which of the following statement is correct? Fluid always flows from high pressure to low pressure. False है, false है. Fluid always flows from higher total energy to lower total energy, not high pressure to low pressure. So this is false. CD of an orifice meter is less than the CD of venturi meter. This is true. Come on, read with me. Of course ही बात है, CD of an orifice meter is 0.68 to 0.74, whereas CD of venturi meter is 0.94 to 0.98. So orifice meter CD is lesser than that of venturi meter. Next, all points in the piping system, that lie above the HGL, above the HGL. So my dear students, all those points which lie above the HGL, everybody knows, have negative gauge pressure. For example, the summit of the siphon. Already told you in the classroom, na, the summit of the siphon. So this statement is again true. Okay. Next, the difference between stagnation and static pressure head is always the kinetic head. Yes, this is again true statement. So he is asking which of the following statement are correct. Come on, tell me. B, C and D is your answer. Are wah, Ashu, Rohit, Ja, Sachin, Abhinav, Nikita, दिल जीत लिया बच्चों, दिल जीत लिया, बहुत शानदार. कमला, अभिनव, पूजा, प्रतिभा, माधुरी, शानदार, गजब. चलो अगला क्वेश्चन करें. सो बी सी डी आर करेक्ट. नेक्स्ट, which of the following statement is false? Which of the following statement is false? For the orifice, CD is equal to CC by CV. This is false. Why this statement is false, my dear students? This is false because everybody knows CD is CC into CV. Okay. Next he is asking momentum thickness theta is equal to, and momentum thickness is also written to be as delta double star. The formula is integration 0 to delta u by u infinity 1 minus u by r. This is correct. This one is again correct, my dear students. Okay, so this is the correct formula for momentum thickness. So this is correct. Next, absolute pressure is atmospheric pressure plus gauge pressure. Again, this is true. But don't forget the important points taught to you in the classroom. During our calculations, you should take local atmospheric pressure for calculation. Second important thing here is, my dear students, that you should, during calculation, you must take gauge pressure with sign. Gauge pressure with sign. बोलो हाँ सर, आ गया सर, बहुत अच्छे सर. आइए देखिए सर, आगे बढ़ते हैं सर. Gauge pressure is rho GH is valid for both compressible and incompressible fluid. ये वही बच्चा बता सकता है जी, जिसने डेरिवेशन किया है और बड़े ही सतर्कता से डेरिवेशन किया है, वही बच्चा बता सकता है. सी P इज इक्वल टू रो जी एच जो है, ये सिर्फ इनकम्प्रेसिबल फ्लूइड्स के लिए होता है, कंप्रेसिबल के लिए नहीं होता. सो दिस स्टेटमेंट इज false. But you know the hydrostatic law, that is dP by dH is equal to rho g. This is valid for both compressible as well as incompressible. So what is asking, which of the following statement is false? So what are the statements which are false? A is false and D is false. So A and D is my answer. A and D is my answer. Very good. Aman George, Yashmina, Amit Singh, Rakesh Biswal, प्रतिभा, अनुजवत्स, अमित सिंह, तरुण, माधुरी, रोहित. अरे वाह, समा बांध दिया बच्चों. आओ अगला क्वेश्चन. Read this, read this. Beautiful problem. See, which of the following will be a method to control boundary layers? See, he is not asking that which are the things which are going to increase boundary layer separation. He is asking which of the methods are which are going to control the boundary layer separation. Chalo, by using a blunt. I will give you time for this. I will give you time for this. 1 minute. 1 minute. Tell me the answer in the comment box. 1 minute. Read. Reading is winning. Reading is winning. Come on, guys. I need the answer to this. I need the answer to this. You are the only one who's going to give the answer to this. Very good. दिए जी दिए, आखिरी 10 सेकंड और दिए. अब इससे ज्यादा उम्मीद मत रखना मेरे से. इससे ज्यादा उम्मीद नको करो रे बाबा. So many students are giving the correct answer. माधुरी, अरे it is, oh my god. चलो इसको रोकते हैं जी, इसका कोई काम ही नहीं. आप सही आंसर दे रहे जी, मजा आ रहा जी मेरे को. Which of the following will be a method to control? By using a blunt body with least streamlining. Arre baba, this is going to increase the chances of boundary layer separation. Instead of reducing, it is going to increase the chances of boundary layer separation. Okay, so therefore you should not use a blunt body. So this is not a method to control. By ejecting retarded molecules from the boundary layer. Yes, it is correct. Yes, it is correct. Because the molecules which are near the boundary, they are in trouble. They have lost their momentum. They are not able to move forward. They have become static. So our method will be to eject those molecules out. So yes, this can be one of the methods. By injecting accelerated fluid particles into the boundary. See the word, injecting the accelerated fluid particles. Yes. देखिए बाउंड्री के करीब वाले मॉलिक्यूल बेचारे तकलीफ में हैं. What you do is you send some accelerateds, कुछ जोशीले मॉलिक्यूल्स को अंदर भेजिए दी ताकि वो भी उनके साथ आगे बढ़ जाए. So yes, this is also method. By moving the boundary opposite to the direction. See, this is wrong. This word is wrong. See, the molecules which are in contact with the boundary, they are already in trouble, and you are moving the boundary opposite to that. This will increase the boundary layer separation chances. So this is again not a method to control boundary layer. In case of venturimeter, by keeping the angle below, yes, because yes, you should keep the angle below 7 degree. So E is correct. So B, C and E. B, C and E. Very good. Dev Bhushan, Kamala, Ankit, Sandhya, Shiv Saurav, Ashish, Pratibha, Bitra. शानदार बच्चों. आ जाओ अगला. बताओ 1 मिनट का टाइम दिया. 1 मिनट का टाइम दिया. चलो. Come on. 1 मिनट का टाइम दिया. I'm giving you 1 minute of time. Try and answer this particular problem that is there on the board. Wonderful. Nikhil. There are a lot of problems in which khela hobe. There are a lot of problems in which khela hobe. Batao, what is the answer to this particular problem? See, anyone with the answer? I will be really very happy if you give the answer to this particular problem. See, the answer to this problem is A, Agra. Answer to this problem is A, Agra. See, you know, there the velocity field and the surface normal vector. So this is the surface normal vector and this is the velocity vector. The boundary condition that one, see, everybody knows that, for example, if there is some particular surface is there, there is not going to be any flow across the surface. There is not going to be any flow across the surface. So, and that is represented by the dot product. So answer is A, Agra, for this particular problem, because there is no flow across the surface. Next problem. This is a fantastic problem. This is literally a fantastic problem. Just tell me the answer. I'm giving you 1 minute of time. I'm giving you 1 minute of time. This is again a fantastic problem. Come on, guys. Come on, come on, come on. I'm really happy. You guys are engaged now. You guys are engaged now. I'm really happy. Biprajit, Pradeep, Tarun, Abhinav, Deepak, Praveen, Madan, Rahul, Ramkesh, Ankur. पढ़ो जी, इसका जवाब चाहिए मुझे. फैंटास्टिक प्रॉब्लम, फैंटास्टिक प्रॉब्लम. अंजनी शरण, करेक्ट आंसर. राम कुमार, गिरजा, नितेश, नाबिल, few. Okay, let me just zoom it on your demand. Let me just zoom it. Let me just zoom it. ये लो zoom कर दिए हैं. अभी बताओ, अभी बताओ. लास्ट zoom कर दिए हैं, अब बताओ. I think I should take the lead in this particular problem. I think I should take the lead in this particular problem. Look here. Look what he's trying to say. This is a nice problem. Consider the following below statement. The objects are marked as A1, A2, B1, B2, C1 and C2. Shown in the figure. Among these three, A1, A2, B1, C1. A1, A2, B1 and C1. These are smooth surfaces. Whereas B2 and C2 are rough surfaces. Okay. And Reynolds number is such that the flow over rough surfaces become turbulent and flow over smooth surfaces is considered to be for all the allophiles same. See, look here, the drag on object A1 is less than the drag on object A2. Yes, it is appears to be correct. Why this appears to be correct? Because see, when the flow is going to be from here, na, this is much more streamlined. But when the flow is going to come in from here, this is the sharp edge. This is what edge, beta? This is the sharp edge. And if this is the sharp edge, my dear students, separation chances are going to be there. So A1 is going to have less drag. So drag is not going to be same. Second option is wrong. Drag of object B1 is more than the drag of object B2. It is correct. It is correct. I will tell you why. Because you know this is smooth. This one is what? Smooth. And when it is smooth, see, these kind of questions you will be able to handle if you have watched the videos that are there in my playlist. If you have watched the videos that are there in my playlist, okay. So you know when the fluid is going to pass from here, na, the separation is going to happen early because it's a smooth body. But when the flow becomes turbulent over the rough body, you know, in case of rough bodies, the point of separation is delayed, or the separation of the fluid from the body is delayed, and that is the reason why the drag in these bodies is going to be lesser. You know, this is the main reason why golf ball has dimples. In golf, we can have smooth balls and dimpled balls. So we are using dimpled balls just to make the flow to be turbulent. So drag of object B2 is more than the, this one becomes, if this is correct, this one becomes wrong. Drag of object C1 is more than the drag of object C2. Drag of object C1 is greater than the drag of object C2. This is wrong. Because now the flow is coming in from here, both of them are same, but this one is rough, na? This one is rough. So that's why the drag on C2 will be greater than the drag of C1. So the 6, so which are correct? 1, 3 and 6. So answer is A, Agra. Answer is A, Agra. Fantastic question. Fantastic problem. Answer is A, Agra. Chalo, let us move on to the next problem. The velocity components in Cartesian coordinate in a 2D incompressible flow is this and this. The magnitude of total acceleration at point -1, 1 is. -1, 1 is. Again, I am giving you 1 minute of time. Come on, come on, come on, come on. Solve करिए अभी solve करने वाले questions आ गए हैं. अभी सॉल्व करने वाले क्वेश्चंस आ गए हैं ना. नाउ यू हैव टू यूज योर कैलकुलेटर, use your paper, pen, keep it with you and solve and give me the answer to this particular problem. Come on, come on, come on. Yes, मजा आ गया, मजा आ गया सर. Oh my god, so many of you are saying मजा आ गया सर. अरे और क्या जी, अभी फ्लूइड मैकेनिक्स है तो मजा तो आना ही है. फ्लूइड मैकेनिक्स है तो मजा तो आना ही है. Come on, solve this. I'm waiting for your answers. I'm waiting for your answers. Aditya Binaya, wrong answer. Aditya Binaya, wrong answer. Abhinav Umang, wrong answer. Deepak Kumar, wrong. Arey, why the hell everyone is giving wrong answers? I really don't know. Why are you giving wrong answers, bhai? Come on, come on, come on. Last 48 seconds. Last 48 seconds. Oh, a lot of you are giving wrong answers. I hope you guys know how to solve this. I am amazed to see that a lot of you are giving wrong answers to this. Last 30 seconds, beta. Last 30 seconds. Now few of you are giving correct answer. Very good, very good, very good. Come on, come on, come on, guys. Yes, that's the way to go. See the answer to this particular problem. Last 12 seconds. Is D Delhi. The answer to this particular problem is D Delhi, and a lot of you are doing mistakes. I don't know why. See, he is asking for total acceleration. He is asking for total acceleration. Everybody knows that total acceleration will be under root of ax ka square plus ay ka square, as it is a 2D flow. So you need to calculate ax. You need to calculate ax. What will be the formula for ax? U into del u by del x plus v into del u by del y plus del u by del t, as it is 2D, and you know del u by del t will also be 0, as you can see that there is no term of time. It is only dependent on space. Okay, so there is no term of time in this. So acceleration in x, let us find out. U is going to be e to the power y cos x into del u by del x. Del u by del x will be e to the power y, and cos x differentiation with respect to x will be minus sin x. This will be minus sin x. Excellent, bacha. Plus v. V is what? E to the power y sin x. Wonderful. And next term is del u by del y. Del u by del y. So therefore del u by del y is going to be e to the power y, but this is cos x term and you are differentiating with respect to y, so it will remain same, cos x. Getting my point? So this is, oh my god, this is going to come out to be e to the power 2y, and of course with minus sign, of course with minus sign, because minus is there. So e to the power 2y cos x sin x, and this will be e to the power 2y sin x cos x. लो जी, इसका तो खेल खत्म, खेला हो गए. This is 0. इसका तो खेल हो गया जी. This is 0. Next is acceleration in y. So let us calculate acceleration in y. U into del v by del x plus v into del v by del y. Del v by del y plus del v by del t. The local acceleration term is 0 because there is no term of time in this. So acceleration in y is going to be u. What is this? E to the power y into cos x. Wonderful. And del v by del x. Del v by del x. So therefore del v by del x is going to be, del v by del x is going to be e to the power y, e to the power y, and sin x differentiation is going to be cos x plus v. What is v? E to the power y sin x. Okay, into del v by del y. Del v by del y will be e to the power y sin x. So my dear students, this will be e to the power 2y cos square x plus e to the power 2y sine square x. So this is going to be e to the power 2y, you take common, what it is going to be? Sine square x plus cos square x, and this is 1. This is 1. So what is the value of a to the power y? A to the power y is e to the power 2y. But you need to find the acceleration at what point? You need to find the acceleration at what point, beta? You need to find acceleration at point, you need to find acceleration at point minus 1 comma 1. So minus 1 comma 1 will be e square. So acceleration at y at minus 1 comma 1 will be e square. And when you are going to put into this, this is 0 and e square, it will be e to the power 4 under root. So answer will be e square. How many of you got the correct answer? How many? Are wah! Excellent. I'm really happy. I'm really happy. See, I have chosen this question particularly because a lot of you are going to do silly mistakes. I know it. मेरे को स्टूडेंट्स का नब्ज पता जी. I know the nubs of the student. You are, see, a lot of students gave the wrong answer. चलो इसको करो 1 minute. 1 minute इसको करो 1 minute. चलो चलो चलो, come on, come on, come on. I need the answer to this. I need the answer to this. Come on guys. आंसर्स आते रहने चाहिए, आंसर्स आते रहने चाहिए. गौरव राय, अनुराग, आकाश, आशु, विपुल, बहुत उम्दा बच्चों, बहुत उम्दा. लगे रहो. आज रुकेंगे नहीं जब तक मेरे प्लान्ड क्वेश्चंस खत्म नहीं हो जाते. आज हम रुकेंगे नहीं, ठीक है. आज हम मन बना के ही आए हैं जी. आज एफएम को ही दिए हैं सब, दुनिया जहान. वाह, इसका आंसर सभी लोग सही दे रहे हैं ऑलमोस्ट. अंजनी, अभिषेक, गौरव, नबील, अम्बरीश, रोहित सही आंसर दे रहे हैं. तो ऐसा करते हैं, इसका टाइमर रोकते हैं बिकॉज आप सब सही आंसर दे रहे हैं उसको. देखो, पावर इनपुट टू अ सेंट्रीफ्यूगल पंप. सो पावर इनपुट, कलर चेंज कर लेते हैं. पावर इनपुट इज अ फंक्शन ऑफ, क्या क्या है भाई फंक्शन? डिस्चार्ज है, डायामीटर डी, रोटेशनल स्पीड ओमेगा है, और क्या है? डायनेमिक विस्कोसिटी म्यू है, और सरफेस रफनेस के है. सरफेस रफनेस के है. बेटा यूनिट्स आपको पता होने चाहिए. देखो, क्यू का डायमेंशनल फॉर्मूला होगा ml-3. दिस इज मीटर क्यूब पर सेकेंड ना. अच्छा, ये तो भाई उसका हो गया, ये तो डेंसिटी का लिख दिया मैंने. आओ, डिस्चार्ज का यूनिट क्या होता है? मीटर क्यूब पर सेकेंड. सो दिस इज गोइंग टू बी L क्यूब टी टू द पावर -1. डी का डायमेंशन होगा L. ओमेगा दैट इज रोटेशनल स्पीड का होता है टी टू द पावर -1. म्यू का यूनिट क्या है? kg पर मीटर सेकेंड, दैट इज ml-1 t-1. and last one is k, which is surface roughness. K surface roughness will be height and its unit will be L. अब देखो, तुम्हें वो कह रहा है, he is asking कि for Buckingham pi theorem which one should be chosen as the repeating variable, and this is a gate question, so you have to solve in a fast manner. See, the repeating variable, 3 repeating variables you will choose here, because options there are 3 repeating variable sets are there. But you should choose the repeating variable in such a manner that one should be geometric, one should be kinematic, and one should be dynamic. Achha, you know what is the reason behind choosing one geometric, one kinematic, and one dynamic? Because you need all these fundamental dimension, mass, length, and time in your repeating variable. They should be there. Okay, chalo, let us check the option. In the first option, Q unit is L cube t to the power -1, omega is t to the power -1, and d is length only. So what is missing? The fundamental dimension, mass is missing. So this cannot be the set of repeating variables. This cannot be the set of repeating variables. Next is what? This is again L cube t -1. This is again length. Again, my dear students, mass is missing. So this can't be repeating variable. Here, अच्छा, density भी है क्या अपने पास? हाँ जी, density भी है. Density का unit क्या होता जी? That is meter cube per kg. That is L cube t to the power -1. density. Density is kg per meter cube na, so that will be your m L minus 3. चलो इधर देखो, so therefore k is again, this is in L, this is in L, but rho is your M L minus 3. Here in this particular set, time is missing, fundamental dimension time, this can't be there. Now let us check this one. Here you know diameter is length, density is ML minus 3, and this is T minus 1. Yes, this satisfied everything. So answer is D, Delhi. Answer is D, Delhi. Answer is D, Delhi. Excellent, excellent, excellent. Wonderful. देख लेना बच्चों, अच्छा प्रॉब्लम था. चलो आगे बढ़ते हैं. ये वाला तो इजी है. अभी अभी मैंने आपको बताया कि गोल्फ के बॉल पे डिंपल्स क्यों होते हैं. तो a golf ball is having a dimple to make the flow turbulent to reduce the drag. Turbulent flow reduces on the ball because, yes, C is the correct answer. Turbulent flow has a lower tendency to separate. I told you na, if the flow is turbulent over the ball, the separation will be delayed. And once the separation is delayed, the vacuum zone which is created behind the body is lesser in comparison to a smoother ball. So answer is C, Chennai for this. Answer is C, Chennai for this. Yes, chalo, let us move on to the next problem. Let us move on to the next problem. Again, I am giving you 2 minutes of time. Come on, come on, come on. I am giving you 2 minutes of time. Let us move on to the next problem. Wonderful. Let me drink some water. And 2 minutes of time are there. Tell me the answer to this. Options are on the next slide. These are the options. First you read the problem. First you read the problem. Then I will show you the options. First you read the problem, then I will show you the options. Come on guys. अभी वॉर मोड में होने चाहिए आप. अभी एकदम अपने टोज पे होने चाहिए. एकदम टोज पे होने चाहिए. Ready to go. Ready to go. We are in war mode at the moment. बिल्कुल वही एंथू रखना है जो कि गेट के पेपर के टाइम आप रखेंगे. ठीक है, सवाल दिख गया? Options दिखाऊं? Should I show you the options? Tell me in the comment box. Should I show you the options? Are you through with the question? चलो, ये है option. Last 45 seconds. Last 45 seconds to give me the answer. Last 45 seconds to give me the answer. Come on, come on, come on guys. समयबद्ध तरीके से जवाब देना जरूरी है. समयबद्ध तरीके से जवाब देना जरूरी है साथियों. चलो, C is the wrong answer. I don't know why a lot of you are giving answer as C, Chennai. C, Chennai is the wrong answer. C is the wrong answer. Ashu, Anjani, Anurag is the wrong answer. इधर देखिए, I will tell you. Answer is D, Delhi. Answer is D, Delhi. How the answer is D, Delhi? Just look. How the answer is D, Delhi? See, my dear students, look here. Everybody knows that in this particular problem, na, just wait a minute. In this particular problem, he has given that the Reynolds number is less than 1. So we can assume that the Stokes law is applicable. Stokes law is applicable. And CD for a sphere which is kept in a flow according to Stokes law is 24 by Reynolds number. Is 24 by Reynolds number. Do you remember this? I told you to remember the direct formula for drag over the sphere kept in a fluid. So you know when the fluid is going to come over from here, you know there is going to be tension that is going to develop in the string. And tension will have two components. Tension will have two components. This component will be T cos theta and this component of tension will be T sin theta. So that T cos theta and fluid is coming in from here, so the drag is going to be in this direction and the weight of this sphere is going to be in downward direction. So this is how the force balancing is going to be done. So let us balance. So T sine theta will be equal to the weight. So T sine theta will be equal to the weight. What is weight? If you are my student, nobody can forget that how to write weight of anything in fluid mechanics. Everybody knows that rho GV, rho GV. So it is rho into G into volume. So volume of the sphere is 4 by 3 pi r cube, but if you write in terms of diameter, it will be pi d cube by 6. It will be pi d cube by 6. 4 by 3 pi r cube, if you put r is equal to d by 2, then you are going to get this. So let this be 1. What will be next? T cos theta will be equal to drag over the sphere. And everybody knows, if you remember directly, drag over the sphere is 3 pi mu u infinity into diameter. 3 pi mu u infinity into diameter. Let this be 2. If you divide both of them, you are going to get the value of theta. If you divide both of them, you are going to, so this is rho of the sphere. So if you divide both of them, you are going to get the value of theta. Answer is going to be D del E. Answer is going to be D del E. So this will come out to be tan inverse. When you are going to divide 1 and 2, T and T will get cancelled out. It will become tan theta. So our answer is going to be tan inverse 1 by 18 rho of sphere d square g divided by mu u infinity. This is going to be our answer. How many of you gave the correct answer? A lot of you. Vikas, Madhuri, Pooja. Oh my god, the cursor is moving so fast. Let us move on to the, now this is a fantastic problem. This is a fantastic and a mind-boggling problem. It is my humble request you please observe on the board. A two-dimensional laminar viscous fluid film having constant thickness H steadily flows down as shown in the figure. If the velocity profile of the liquid film is u is equal to ky in brackets 2h minus v and the y component of velocity is 0, the value of constant k is. So you know there is this sloping surface is there, and over that sloping surface there is a viscous liquid is there which is moving, my dear students. The constant height is h. Gravity is of course in downward direction. The angle is given as theta. He is asking you that in this velocity profile, what is the value of this constant k? What is the value of this constant k? Come on, anyone in the class? Chalo solve karo isko. Let us solve. See my dear students, here we are going to utilize the Navier-Stokes equation. But before that, what is the velocity distribution given? U is equal to ky 2h minus y. So the value of u is 2kyh minus ky square. Wonderful. Let us use the Navier-Stokes equation in x direction. But please, it's my humble request. Look, the direction x is like this. Please don't forget that. The direction x is like this. So if the direction x is like this, you will be needing the gravity component in the x direction for solving the Navier-Stokes equation. So you know this is gravity. If this angle is theta, this is 90 minus theta. Beta, please be with me in this particular problem. So if this is 90 minus theta, the component of gravity in this is going to be, gx is going to be g cos 90 minus theta, and which can be written as g sine theta. Because we need the component of gravity in this. Now let us apply the Navier-Stokes equation in x direction. Now what is Navier-Stokes equation, beta? Navier-Stokes equation is rho material derivative of your velocity vector, but we are solving in x direction. We are solving in x direction, so we are going to put u minus of del p by del x plus mu times the Laplacian operator of u plus rho g and gravity in x direction. This is your Navier-Stokes equation in x direction for incompressible fluid. For incompressible fluid. So how you are going to write this? This is going to be rho ax, because you know du by dt is nothing, it is ax. Huh? And let us, because he is not talking about any kind of pressure gradient in this particular problem, so therefore pressure gradient we are taking it to be as 0. Okay dear, and rest of the terms are going to be written like this. So this is mu, this is del square u by del x square plus del square u by del y square plus rho gx, and gx is going to be g sine theta, Wonderful. Chalo, see, this is the velocity distribution. So let us first of all calculate del u by del y. Because you know del u by del x, see, in the velocity distribution there is no term of x. Please be with me in this particular problem, be with me. Whether you have given the answer or not, it doesn't matter to me. You just be with me and see a different approach, how we are applying the Navier-Stokes equation to this particular problem. So be with me in this particular problem. So you know there is no term of x in this, so this term is going to be 0, my dear students. Huh? And yes, with respect to y, so del u by del y. So if you differentiate it with respect to y, this will be 2kh minus 2ky, and if you double differentiate this, del square u by del y square, this is going to be minus 2k. This is going to be minus 2k. What else do you want to solve this? You need acceleration in x direction. Chalo, let us find the acceleration in x direction. So acceleration in x direction is nothing, it is u into del u by del x plus v into del u by del y plus del u by del t. How many of you know this is going to be 0? And v is again 0, so this is also gone. V is again 0, so this is also gone. Okay. And what is next? So acceleration in x direction is going to be u into del u by del x. So u into del u, oh no. So, oh my god, this is again 0 because there is no term of x in this, and this is 0 because v is 0. So acceleration in x direction is 0. So the left hand side becomes 0, is equal to the value of del square u by del y square is how much? Minus 2k, and mu is waiting outside, plus rho g sine theta. So this is going to be 2k mu is equal to rho g sine theta. You need the value of k, so k will come out to be rho g sine theta divided by 2 mu. Rho g sine theta divided by 2 mu. I have given you a see, I can solve this particular problem just by using the Bahubali equation. Tau is equal to mu into du by dy. I can solve this particular problem. But I wanted to give you a different approach. Sometimes the approach matters more than your answer. Sometimes the approach matters more than your answer. So what rho g sine theta by 2 mu. So our answer is A, Agra. Our answer is A, Agra. Are you enjoying this session? Tell me in the comment box. Tell me in the comment box. Are you enjoying this session? Chalo, next problem. Next problem. Let me drink some water. Come on, come on, come on. Next problem. Next problem. Come on, come on, come on, beta. Come on, come on, come on. Try and solve this. For a steady laminar incompressible 2D flow between two horizontal plate, so you know the pressure gradient in x direction and velocity component in y direction. So you know the v component is given to be as 0 and the pressure gradient is also given to be as 0. Okay. See, the upper plate is moving towards right with a speed of u1, the lower plate is moving towards the left with a speed of u2. Then he is asking the correct expression for velocity distribution between the plates is. The correct expression for velocity distribution between the plates is, my dear students, see, you know I can solve this particular problem within seconds. But I told you now, approach matters most. Approach matters most. So again I am going to apply the Navier-Stokes equation. So let me apply the Navier-Stokes equation again here. So my dear students, this is, what is the Navier-Stokes equation in x direction? It is rho acceleration in x. Arey bhaiya, rho acceleration in x minus of del p by del x plus mu times of u plus rho g x plus rho g x. Excellent. My dear students, come on, tell me the answer. Yes, it is A, Agra. It is A, Agra. The answer to this particular problem is A, Agra. See, gravity in this particular case, gravity let us take in z direction. Let us take gravity in z. See, taking gravity is our, so let us take gravity in z direction. So this is taking as 0. I need to find acceleration in x. So acceleration in x will be u into del u by del x plus v into del u by del y plus del u by del t. See, it is a steady flow. Beta, please concentrate on board. As it is a steady flow, local acceleration is gone. See, the y component of velocity is given to be as 0. So this is 0. So this term is again 0. And you know, why don't you try and understand that u is a function of y only. Baba re baba. As it is a steady laminar incompressible flow, u is only varying in y direction and not in x direction. Try and understand that. So u is a function of y only, not a function of x. Okay. So therefore, so u is not a function of x. Wonderful. Just look at the beauty. Acceleration in x is 0. So acceleration in x is 0. And I hope you guys know that del p by del x is also 0. It is given in the problem. So what is remaining? 0 is equal to mu into del square u by del x square plus del square u by del y square. Now how many of you know again that u is not a function of x? If u is not a function of x, u is constant with x, so this term is also gone. If this term is also gone, this becomes 0. So what you are going to get? Del square u by del y square is equal to 0. Let us integrate. You want the velocity distribution, na? Let us integrate. So this is going to be du by dy. So du by dy, 0 integration will be some constant. Integrating again, so u is equal to c1y plus c2. Now how to get the values of c1 and c2? Let us go for boundary conditions. Boundary conditions. What are the boundary conditions? Come on, come on. So this is y. This direction is y. So at y is equal to 0, u is equal to minus u1. Sorry, minus u2, because it is in opposite direction. And what will be the second boundary condition? At y is equal to b. At y is equal to b, u is equal to u1. U is equal to u1. So if you put the first boundary condition that at y is equal to 0, u is equal to minus of u2. So in place of u, you are going to put minus of u2 is equal to c1y. And this is 0. This is 0. So the value of c2 will come out to be minus u2. So if the value of c2 comes out to be minus u2, this is going to become u is equal to c1y minus u2. Wonderful. Now you need to find the value of c1. Let us apply the second condition at y is equal to b. at y is equal to b, u is equal to u1. So when you are going to put this, my dear students, the value of c1, you are going to get as solve. The value of c1 from here you are going to get as u1 plus u2 by b. So when you are going to put all this stuff into the equation, which option you are going to get? You are going to get the option as C1 value is this. If you put in this, C2 is minus U2. So you are going to get the option as A, Agra. Fantastic question again. Mind-boggling problem again. Let me tell you a trick to solve this. If you are attentive and you have IQ in the examination, you can use a trick. What is the trick? See, all these are velocity distribution. So our velocity distribution should satisfy the boundary condition. So what is the boundary condition? At y is equal to 0, u is equal to minus u2. So let us put it here. At y is equal to 0, will our u become minus u2? Come on guys, I am telling you a trick directly. Just by looking at the option without the Navier-Stokes equation, without this approach, you can tell the answer just by looking at the answers. See, at y is equal to 0, u is equal to minus u2. Yes, it is coming. What is the next condition? At y is equal to b. U is equal to u1. So at y is equal to b, b and b will get cancelled out. u2. Arre gazab. Beautiful, it is coming out to be u1. So it is A only which is satisfying our boundary conditions which are given in the question paper. मजा आया कि नहीं यार? मजा आया कि नहीं आया? So answer is A, Agra. Chalo, solve this. I am giving you 2 minutes of time to solve this. Come on. Timer start now. I'm telling you now. This is such a quality question. Come on. I need the answers, beta. Let me drink some water. Hari Narayan, boom bam. धमाकेदार क्वेश्चन, धमाकेदार है ही और ये क्वेश्चन और ज्यादा धमाकेदार है, मजेदार क्वेश्चन है क्योंकि इस प्रकार के क्वेश्चंस, yes, you are going to revise a lot of things. Come on guys, come on. See, we are moving in a random manner. We are not moving chapter wise. I need the answer to this. This is NAT, that is numerical answer type question. I need the answer to this. Last 57 seconds. Last 57 seconds. Very good. Madi Reddy has given the correct answer. I am very happy. Yasarappu, Chandan Vispute, you are very close to the answer but not the exact answer. Exact answer is 0.83. Salabega Padhan. अरे हाईली इम्प्रेस बेटा, हाईली इम्प्रेस. छा गए आप लोग छा गए जी इतना बड़ा भीड़ में. इफ यू आर एबल टू सॉल्व दिस क्वेश्चन विद इन 2 minutes, आई रियली अप्रिशिएट. अभिषेक मिश्रा, अभिनव कुमार, अंजनी शरण, मजा आ गया जी. आ जाओ, चलो करें सॉल्व, देखें इसको. आओ देखो, हो जाएगा, कोई बड़ी चीज नहीं है बट अच्छा प्रॉब्लम है. देखो, the diagram to this particular question will be something like this. The diagram to this particular question will be something like this. Chalo, let us solve this particular problem. See, there is a tank is there in which some water is there, some orifice is there whose diameter is given to you in the problem. Also the discharge with which the water is coming out from this is also given to you in the problem. Now to resist, see, the water jet is coming out from air and the water jet is working under a constant head of 2.75 meter. Okay, so when the water jet is going to come out from here, na, that is going to apply force over the plate, and you, to hold the plate in position, you are applying 310 Newton. See, why I have chosen this particular problem is many of you, they ask me that, sir, how in laboratory CD, CC and CV all this stuff is calculated? My dear students, in our classroom we have briefly discussed how experimentally we can find the value of CV. This is how, these are several methods can be there, how you find out the CD, CC and CV of particular things. Okay, chalo. See, the discharge is given to you. And area of the, first of all find the area of the orifice. So area of the orifice is going to be pi by 4 into do square. So when you are going to solve this, I am already having the answer, so I will tell you the answer. This will be 0.007854. 0.007854 meter square is the theoretical area of the orifice. Next, if this is the theoretical area, then this is the theoretical discharge. Theoretical discharge is, see, this is the actual discharge. See, because this discharge is coming from experiment, na, he is giving this discharge. So this is the actual discharge. This is the Q actual. Okay, we need to find the theoretical discharge. So this is the theoretical area. If you multiplied this theoretical area with the theoretical velocity, so how to find theoretical velocity? Everybody knows that theoretical velocity for this particular case will be under root of 2gh. Will be 2 into g is 9.81 or 10, whatever, what is given in the problem, nothing is mentioned, so we will take 9.81 into height is 2.75. So from here we can find out the value of the theoretical velocity, which will come out to be 7.345 meter per second. Now can you find the theoretical discharge? Yes, theoretical discharge will be A theoretical into V theoretical. So theoretical discharge will come out to be 0.05769, 0.05769 meter cube per second. Now once this is the actual discharge, this is the theoretical discharge, so can you find the value of CD? CD will be Q actual by Q theoretical. So Q actual by Q theoretical, the value of CD will come out to be 0.78. 0.78. This is the value of CD. But you need not find the value of CD. You need to find the coefficient of contraction. So we have to keep on moving. Actually, we can find out the value of CV here. How? See, this force is given. This force is given. So the force applied by the jet is, everybody knows this is a very general case. A jet hitting a plate or something like that, the force exerted is rho a v square, or in other language you can say rho q v. So rho q v should be equal to 310. Rho q v, and this will be actual velocity, should be 310. Discharge you know, density you know, can you find the value of V actual? Yes. So V actual you are going to get from here is 6.889. 6.889 meter per second. Once you get actual velocity, you have theoretical velocity. Can you get the value of CV? Yes, CV will be V actual by V theoretical. So V actual by V theoretical, when you are going to divide this, you are going to get the value of CV as 0.9379. 0.9379. Fantastic question according to me. So what is the relationship? CD is equal to CC into CV. So CV will be CD by CC. Acha, you need to find CC. You need to find CC, not CD. Just a moment. So CC is going to be CD by CV. So when you are going to calculate this, the value of CC will come out to be 0.832. 0.832. Mind blowing problem. That's your answer. Mind-blowing problem. Yes. Shubham, Harshad, Ambrish, Arpit, Shailendra, रामकेश, इसे कहते हैं प्रॉब्लम. आप लेवल देखो एंड डोंट थिंक that these kind of problems can't be asked in GATE paper, blah 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 blah. A lot of things. See, you're using the concept of a jet hitting over the plate, you're balancing that force, you're finding actual. So by this single problem I have given you a complete idea that how all this CD, CC and CV of the orifice are calculated in real life in the laboratory. Chalo, next are these. I'm telling you now, this is ultimate question. Let me handle this problem, beta. It is my humble request to you guys. Let me handle this problem. Humble request. Let me handle this problem. The velocity profile for a turbulent flow through a pipe is approximated as U by U max 1 by 7, Y by R 1 by 7, where U max is the maximum velocity normal to a pipe, U average denotes the average velocity in the pipe, then the ratio of U average by U max is, then the ratio of U average by U max is. My dear students, let me handle this problem with care. First of all, see, U by U max is given to you as Y by R raised to the power 1 by 7. So from here the velocity distribution can be written as U max Y by R raised to the power 1 by 7. Now what do you want? You want the value of U average by U max. Huh? Now everybody knows that discharge in terms of average velocity. For a pipe. See, we are talking about pipe na beta. Having a radius of R. And this is the velocity distribution for turbulent flow in a pipe. This is not an easy problem. Kindly look at on the board. Look here on the board. So discharge in terms of average velocity. How to write discharge in terms of area multiplied by average velocity. Here the average velocity is shown like this. So discharge is written as pi r square into U average. Wonderful. This is one of the values of discharge. Let this be 1. Okay. Now one more discharge we can find by integration, by using local velocity. Everybody knows that. See, but the local velocity is changing. This is the local velocity, na? The local velocity is changing along the radius. So therefore we have to take a small ring. वही अपना पुराना खेल करेंगे. So for this small ring, let us find the small discharge. So for this small ring, the small discharge is going to be U into dA. So total discharge will be integration 0 से R. The value of U is how much? The value of U is U max Y by R raised to the power 1 by. If you are with me, if you stay with me now, I am going to give you the real approach for solving this particular problem. But if you stay with me for the next 5 minutes now, I will tell you a shortcut for all these problems. I will tell you the shortcut for these problems, and I have given the shortcut in QRC course. But at the moment you look at dA will be 2 pi r into dr. So my dear students, discharge can be written as, see, 2 pi U max has nothing to do with integration. So what is remaining inside? Integration 0 to R Y by R raised to the power 1 by 7 into R into dr. I really don't know whether anyone has noticed or not, but the equation is given in terms of y. But you are integrating with respect to r. So what, क्या माजरा है ये, क्या माजरा है ये? Do you guys remember that in a pipe, for example, if you are taking any point, then the distance measured from the pipe wall is shown by the symbol Y, and distance measured from the center line is shown by the symbol R. So how many of you are able to understand that R plus Y is always equal to capital R? R plus Y is always equal to capital R. So in place of Y, can I write R minus R? Can I write R minus R? Chalo, let us put it here. So discharge will be 2 pi U max. Please stay with me. This is a fantastic problem. You will learn how to tackle these kind of problems. You will learn how to tackle these kind of problems. Integration 0 से R. In place of Y, what you can write? R minus R by R raised to the power 1 by 7 into R into dr. So my dear students, this can be written as 2 pi U max, integration 0 से R. This can be written as 1 minus R by R raised to the power 1 by 7 into R into dr. Now you know, थोड़ा थोड़ा हमें मतलब अनजानी इक्वेशन से थोड़ा सा हम लोगों को एक ठीक ठाक सी इक्वेशन मिल गई है. अभी इसको कैसे सॉल्व करेंगे ये देखो. 1 minus R by capital R को let us assume it to be some t. So when I differentiate this will be minus of dr by R is equal to dt. Dr by R is equal to dt. Wonderful. So from here, if you want to replace dr can be written as minus of R dt. Dr can be written as minus of R dt. And what will be the change in the limits, my dear students? So let us also try and find out the value of R. So if you see from here, this can be written as 1 minus t into R is equal to small r. And there will be changes in the limits also, beta. Here the limit is from 0 to R, but now you are trying to convert that in terms of t. And if you are trying to convert that in terms of t, so you know at R is equal to 0. At R is equal to 0, t is equal to 1. At R is equal to 0, just put R equal to 0, t will be equal to 1. And at R is equal to capital R. At R is equal to capital R, t will be equal to 0. At R is equal to capital R, t will be equal to 0. So this is how the limits are going to change. Chalo, look here. So let us convert everything. So this is 2 pi U max. Just stay with me. This is a fantastic problem. देखिए अच्छा चीज को एब्जॉर्ब करने के लिए समय लगता है, ठीक है. अगर आप भागा दौड़ी ही मचाते रहेंगे और यहां से वहां ही भटकते रहेंगे तो मुझे नहीं समझ आता कि आप ज्ञान की प्राप्ति कैसे करेंगे, ठीक है. अगर आपके शिक्षक कुछ अच्छा बताने की कोशिश कर रहे हैं जिसमें समय लग रहा है, आपको कुछ नया सीखने को मिल रहा है, कैन यू सी दीज प्रॉब्लम्स आर डिफरेंट, they are different. I've chosen these problems, that is the reason why I've chosen these problems. But आप अगर यहां से वहां ही, इसलिए मैंने बोला था पूरा अटेंड कीजिए, तभी आप समझ पाएंगे कि कैसे ये सब चीजें हो रही हैं. So 2 pi U max, you know when this is 0, this is 1, and when you put R, this is 0. Getting my point? When R is equal to capital R, t, because you are converting in terms of t, na. 1 minus R by R you have taken to be as t. So this will become t to the power 1 by 7. What is the value of R, beta? Value of R, where it is? Here it is. It is 1 minus t into R. This is 1 minus t into R into dr. And how to write dr? How to write dr? Minus of R dt. So this is minus of R dt, minus of R dt. See, when you are going to bring minus sign outside, to absorb that minus sign, the limits will get reversed. The limit will, to absorb that minus sign, the limits will get reversed. So when you are going to overturn the limits, see, discharge is going to come out to be 2 pi u max, 2 pi u max. And see, capital R and capital R are constants, they can be taken outside, so this is r square, 2 pi r square. And if you want to absorb the minus sign here, the limit should be overturned, so this is 0 to 1. What is remaining inside? Now you can integrate easily, you can integrate. So what is remaining? What is remaining inside this? So this will come out to be t raised to the power 1 by 7 minus, if I am not wrong, yes, minus t raised to the power 1 by 7 plus 1 into dt, into dt. Now this integration has become an easy integration. Now you can solve. Now you can solve. 2 pi u max r square integration 0 to 1. Chalo, let us integrate. Itna kya karna? So t raised to the power 1 by 7 plus 1 divided by 1 by 7 plus 1 minus t raised to power 1 by 7 plus 1 plus 1 divided by 1 by 7 plus 1 plus 1. And limits will be from 0 to 1. See, to solve this, easy, take LCM, do the numerator. Let me tell you that directly, let me tell you what it is going to be. And you know the value of Q. See, easily you can solve this. Now this is solvable. I have brought it down to this level, okay. Look here. Now, what is the other value of discharge? Pi r square u average. So, in place of discharge, let us put pi r square u average is equal to 2 pi u max r square, okay. And the value of this you should solve. This is your responsibility now. The value of this you are going to put here. So when you are going to cancel out all this stuff, and you are going to get the value of u average by u max as 49 by 60. You are going to get it as 49 by 60, and that's your answer. That's your answer. Fantastic. Lot of you are giving the correct answer. I am highly impressed. Biprajit Paul, correct answer. Animit Srimani, I am highly impressed. See, I promised you that I am going to give you a shortcut. I promised you, na? Now the shortcut is coming. Look here. This shortcut I have given. See, the method is this only. But let me tell you the shortcut. With the help of this, you can tackle these kind of problems directly. Directly you can tackle these kind of problems. The shortcut is this. The shortcut is here on the board. Shortcut is here on the board. See, whenever the velocity distribution is something like this, look here, whenever the velocity distribution is something like this, u is equal to u max 1 minus r by r raised to the power k, where the k can be any value, whatever is there in the question. This is the shortcut. See, the value of u average is this. If you want the shortcut, remember, because this is also asked in conventional papers many times, okay. This is the value of kinetic energy correction factor directly, okay, and this is momentum correction factor. So please remember kinetic energy correction factor, momentum correction factor, and this. Now, if you remember, what was the value, what is the equation in our case? This is the equation. This is the equation in our case, if you are able to understand, huh? So therefore, directly by using this particular formula, you can get the answer. What is the value of k? K is 1 by 7 in our problem. K is 1 by 7 in our problem. K is 1 by 7 in our problem. My dear students, I would like you to cross verify at home. I would like you to cross verify at home. So all these formulas for this particular equation that you are going to get in a lot of question, you should note this down in your main register. In your main register you should note down this, okay. Chalo, let us move forward. चलो इसका तो आंसर ये देखो आसान वाला आ गया. देखो कठिन क्वेश्चंस के बाद थोड़ा सा सांस लेने का समय, थोड़ा सा सांस लेने का समय है, थोड़ा सा सांस लेने का समय. 1 मिनट का टाइम है बच्चे, जल्दी बता दे. 1 मिनट का टाइम है, जल्दी बता दे. Few of you are asking what is M, sir. Few of you are asking what. Few of you are asking what is M, sir. Just a moment. Oh, that question got deleted. That question which was there on the board got deleted, unfortunately. Don't worry, it was a normal stable equilibrium question. It was a normal stable equilibrium question. Unfortunately, that question got deleted by me. See, this M is K only, beta. The denotation, okay? M is K only. M is K only, okay? M is K only. Unfortunately, that question of stable equilibrium got deleted by me, and that is not there in the slides. So by mistake it got deleted. But see, this is going to be in the YouTube session, so you pause the video there. I think the answer was D, Delhi. If I'm not mistaken, the answer is D, Delhi. You solve this one. You solve this one. I'm giving you 2 minutes of time. Solve this one. Come on guys. Madan Prajapat, Abhinav, Anjani Sharan. Correct. The answer was D, Delhi to that question. But गलती से मेरे से वो delete वाला निशान दब गया. तो it was an image. तो वो चला गया. But कोई बात नहीं. Solve this. Solve this. I'm giving you 2 minutes of time. This is an easy problem. Come on guys. Come on guys. अभी जज्बा है जी. अभी जज्बा है. अभी कुछ कर गुजरने का जज्बा है. जल्दी कीजिए साथियों. 1 minute and 17 seconds. Let me drink some water before I give you the answer to this particular problem. Let me drink some water. अरे एक बारी कमेंट बॉक्स में आप ही लोगों की भाषा में बात कर रहा हूं. Tell me in the comment box whether you are enjoying this session or not. Just tell me in the comment box. देखो, मैं भी आप लोगों के साथ बहुत मेहनत कर रहा हूं यहां पर. I'm trying my level best. अब देखो, GTQ 1, GTQ 2 के बाद different questions लाना is a difficult task. फिर भी आप देखो quality of questions. Last 30 seconds. चलो, वो सब छोड़ो. अभी तक इसका जवाब किसी ने नहीं दिया भाई. अभी तक वो छोड़ो. हाँ, enjoying ठीक है. इसका जवाब दो भाई. enjoying चलता रहेगा. 5 is correct answer. 5 is correct answer. भैया टाइम खत्म हो गया जो 2 मिनट का दिया गया था. आओ निपटाते हैं इस सवाल को. ये देखो, बड़ा ही आसान सा सवाल है. यहीं पर खत्म कर देंगे. देखो, इंपॉर्टेंट चीज है इनकम्प्रेसिबल और स्टेडी फ्लो. इनकम्प्रेसिबल और स्टेडी फ्लो है तो एक वन थिंग इज गारंटी दैट वॉट एवर इज कमिंग इन हैज टू गो आउट. Okay, so for example, in between these two plates, let me take this section as 1 and let me take this section as 2. Okay, so whatever is coming in, so m dot 1, so m dot, as it is a steady flow, the mass flow rate has to be same, na? So m dot 1 will be rho into area. What is m dot? M dot is rho av, but at the entry the velocity is constant, so you need not integrate. So rho into area. What is the height of this between the plates is y naught. So y naught is the height multiplied by depth is 1 multiplied by u naught. My dear students, u naught is given to be this. Just take care of the units. See, 5 is also correct answer. 5 is also correct answer and 500 is also correct answer. I will tell you why. If you find the answer in centimeter per second, if you use the centimeter terms, I think the answer will come out to be 5. But if you convert it to meter, I think the answer will come out to be 500. I think so. You can cross verify. But the main aim is not the answer. The main aim is the logic behind the question. Okay. So when you are going to multiply this, this will come out to be 1.8 kg per second. This will come out to be 1.8 kg per second when you convert everything in meter. But at the exit, the velocity is varying. Many times we have solved like this. If the velocity is varying, then let us take a small strip having a height of dy, integrate karna padega na. So let us find the small mass flow rate. Small mass flow rate will be rho into area of the strip is dy cross 1 multiplied by velocity is u. So therefore what will be the total mass flow rate exiting from 2? It will be integration from 0 to y naught. And this is going to be rho into u. What is the value of u, beta? The value of u is here. See, this is given in the problem. The value of u is a y naught minus a y square into dy. Are we clear? Yes, wonderful. Yes, 5 or 500 is the correct answer. I don't have. Now simple integration is there. All the values are given. Just do this simple integration. You will get your answer. So this upon integration, this will come out to be rho a. This will come out to be rho a y naught cube, if I am not wrong, divided by 6. What you do is you equate m dot 1 is equal to m dot 2. So when you are going to equate, either your answer is going to come out to be 5 or either the answer is going to come out to be 500. Both the answers are correct. Both the answers are correct. Both the answers are correct. Just the units are different. And in this particular problem, he hasn't mentioned that A you should find in which unit. So both the answers are correct. Chalo, let us move on to the next problem. Now this is a mind-blowing problem. You will learn a lot of things in this problem. Should I give you time to solve this or should I handle this? Chalo, मैं ही handle करता हूँ इसको. I will solve this. Okay. You please concentrate on the board. For a 2D incompressible flow. Okay. Now this is your U and this is your V. Then he is asking obtain the stream function and the discharge between the points 2, 3 and 3, 4. So my dear students, first of all let us write U. What is the value of U, beta? U is given to be as y cube by 3 plus 2x, y cube by 3 plus 2x minus x square y, and what is the value of V given, bache? V value is given to be as xy square minus 2y, just a moment, minus 2y and minus x cube by 3, See, first thing you should always cross verify as he is asking for stream function. If he is asking for stream functions, do you guys realize that stream function is only existing when the flow is possible? The flow has to satisfy the continuity equation. So let us check for continuity. 2D incompressible. So 2D incompressible, the continuity equation is del u by del x plus del v by del y. So del u by del x will be 2 minus 2xy plus del v by del y. Del v by del y is going to be 2xy minus 2. Oh, gazab. So this is going to come out to be 0. Hence flow is possible and stream function will exist. Chalo, let us now find the stream function. Now my dear students, how to find the value of stream function? Let us start with u first of all. So everybody knows u is equal to minus of del psi by del y, isn't it? isn't it the formula for the stream function? Okay, so from here you can write del psi by del y is equal to minus of u, and minus of u will be minus of y cube by 3 minus 2x plus x square y. Beta, if you want the found, hey, this is a very nice problem, a very genuine problem. धमाकेदार प्रॉब्लम है, धमाकेदार प्रॉब्लम है, जेन्युइन प्रॉब्लम है. देखिए, अंत तक क्रीज पर टिके रहना बहुत जरूरी है, क्योंकि अगर आप अंत तक मेरे साथ टिके रहे तो आज हम फ्लूइड मैकेनिक्स के बहुत उम्दा से उम्दा कॉन्सेप्ट्स आज हम सीख कर ही जाएंगे. तो साई का वैल्यू क्या आ गया बच्चे? विद रिस्पेक्ट टू वाई इंटीग्रेट करना है तो माइनस वाई टू द पावर 4/12 minus 2xy plus x square y square by 2 plus a constant, but you are integrating with respect to y, so this will be a function of x. So this is one of the equation of psi. Let us try and find out another equation of psi. How to do that? From v. So v, everybody knows, is del psi by del x, is del psi by del x. So therefore del psi by del x is equal to v, which is xy square minus 2y minus x cube by 3. See, there can be two methods to find the stream function. Okay, you have found it out this. You have found it out this value of sin. I am telling you method number 1. I am telling you method number 1. Just learn from me. First method will be, you have found it out this value of psi. You differentiated with respect to x. You differentiated with respect to x and put it equal to v. Put it equal to v and find the value of f dash x. After finding f dash x, you again integrate that. You will find the value of fx. You put in this. But I am going to tell you one more beautiful way. One more beautiful way. Those of you who are my classroom students, they know how to deal with these problems. Chalo, let us integrate first of all. So psi is going to be x square y square by 2 minus 2xy minus x to the power 4 by 12 plus some constant. That is, let us say, function of y, or some constant is going to be there. Now how to see, this is one of the values of psi, this is another value of psi. How to write final? Now this is the thing which I want to do. Already told to you in the classroom that few terms will be common. Few terms will be common. Few terms will be common. Like, as you can see, minus 2xy and minus 2xy is common in both. And x square y square is common in both. So those terms which are common, do you remember from our classroom interactions? This will be x square y square by 2. You write those common terms once in the final stream function. Only once in the final. Dekho, many students have started to give the correct answer. Pratik Tiwari, Biprajit Paul, Abhinav, अम्बरीश, आयुष, हिमांशु, हुड्डा, मजे आ गए भाई, मजे आ गए भाई. एक्सेलेंट एक्सेलेंट एक्सेलेंट. मैं आपको क्या बताऊं, मेरा दिल गद गद है, मेरा दिल गद गद है कि आप लोग कॉपी पेन लेकर मेरे साथ साथ सॉल्व कर रहे हो. देखो कितने बच्चों का सही जवाब आ गया. 22, approximately 22 units is the correct answer. Is the correct answer. And what was the next thing? Those terms which are not common in both of them, you have to write both the terms. So minus of x to the power 4 by 12 minus of y to the power 4 by 12. Rest of the remaining things can be written as constant. So this is your stream function psi. Now how to solve beta? You need to find at which points 2, 3 and 3, 4. So now it is simple. Find the value of psi at 2, 3. Find the value of psi at 2, 3 and find the value of psi at 3, 4. At 3, 4. आ जाओ जी, psi at 2, 3. So when you are going to solve psi at 2, 3, it is going to come out to be 2.0833 if I am not wrong, plus some constant. Beta, you can always cross verify the answer. You can always cross verify the answers by yourself, okay? And psi between 3 and 4 will come out to be 19.96, 19.9167. 9167 plus some constant. So if you want the discharge, it will be the subtraction of these two, which will come out to be 22 units. Which will come out to be 22 units, and that's our answer. Fantastic problem or not? Just mind-blowing and amazing. Amazing. Amazing, let me tell you. The next problem is just amazing and mind-blowing. Mind-blowing. I am giving you 30 seconds of time to read the problem and make this diagram in your pen, in your paper, okay? I will handle this problem. I will solve this problem. I will solve this problem. Very good. Aman Gaur, Sandeep, Manish, Tara, Anurag, Rohit, Sneha, Navneet, Anvi, Anand, Salabega Padhan, Gazab, fantastic. Now this is amazing and a mind-blowing problem. Chalo, let me read out. Let me handle this problem again. In an irrotational 2D flow, enters a bend. So how many of you remember that pipe bend is an example of free vortex? And if pipe bend is an example of free vortex, then V are equal to constant. If pipe bend is an example of free vortex, what is the governing equation? V are equal to constant. So V can be written as C by R. V can be written as C by R for pipe bends. The pressure head difference between the outer and the inner side of the ball. See, this is the outer side of the wall. This is the inner side of the wall. And if you are my student, you know this, that there is going to be redistribution of streamline across the bend. There is going to be redistribution of streamlines across the bend. Next important thing that one should notice is that there is going to be variation of pressure, and also there is going to be variation of velocity when you move from the inner side to the outer side of the bend. Everybody knows this. See, from here this relation only, na? When the radius increases, the velocity decreases. So when you are going to move from inner side to outer side in a free vortex, the velocity is going to decrease and the pressure is going to increase. So you need to find out the pressure head difference. Chalo, how to do this? How to find out the pressure head difference? Come on guys. You keep on solving. First of all, let us try and find out discharge. See, my dear students, you know the velocity is varying. So if the velocity is varying and you need to find out discharge, let us take a small strip dr. In this particular small strip, fantastic question again, dil jeet liya bhai question ne. In this small strip, let the depth be some 1. So in this small strip, if you want to find out the discharge, this will be integration from R1 to R2. Integration from R1 to R2 and velocity variation V into dr. V into dr cross 1, of course. I think the depth is not given, so it will be considered to be as 1. Wonderful. Very, very good. Excellent. So, see, in place of V, so this is from R1 to R2. In place of V, what you can write is C by R. So, C by R into dr. So constant you can take outside, and this is going to be, look here, this is going to be so this is going to be integration of, this is going to be log R. So log of R2 by R1, when you are going to put the limits. Clear till here? And my dear students, discharge. How you can find the discharge through this? See, one discharge you have found it out by integration. Beautiful. Huh? How you can find the other discharge? How you can find the other discharge? See, other discharge you can find out as the average velocity is given to you. As the average velocity is given to you, that multiply that average velocity with B. So therefore that is going to be 2 cross B, that is 0.3 is also the discharge, is constant log of R2 by R1. See the value of R1, R1 is 0.5. What will be the value of R2? R2 will be R1 plus B. Come on guys, R2 will be R1 plus B, yes or no? So this is going to be 0.5 plus 0.3, that is 0.8. So this is going to be 0.8 by 0.5, 0.8 by 0.5. Can you find the value of constant from here? Yes, definitely you can find. I'm already having the answer. Let me tell you, this will be 1.276. 1.276 will be the value of constant. Once you get the value of constant, can you find the value of V1? Value of V1 will be C by R1 and value of V2 will be C by R2. Yes or no? Then the last step will be apply Bernoulli to find the pressure head difference. Amazing question. Who would see normal questions, that cylindrical vessel, we are rotating, it will form a paraboloid, the height is omega square r square by 2g. Normal questions everybody can do, but just look at the beauty. Because of this, I am really expecting these kind of problem in the GATE paper. अब मैं इससे ज़्यादा क्या बोलूँ, I'm really because you know in this problem vortex is solved, your concept of pipe bend is there, redistribution a student should know, and also Bernoulli's, because you are going to apply Bernoulli's at the last, na? So I'm already having the answer, so I will tell you V1 will come out to be 2.55 meter per second and V2 will be 1.595 meter per second. ठीक है, अभी आंसर नहीं आया है बच्चे, अभी आंसर नहीं आया है, अभी तो हम लोग या तो बर्नौली लगा लो between 1 and 2, because you know na, for free vortex motion the classical Bernoulli's equation will be applicable. The classical Bernoulli's equation will be applicable to find the pressure head difference, or either you can use the governing equation of vortex motion. dP is equal to rho v square by r into dr minus rho g into dz. Everybody knows, I am telling you now, I have given you two methods now. You can apply Bernoulli between 1 and 2, z1 z2 will, see height difference is not there, na? So this is 0, why do you use it? So dP will be integration from 1 to 2, that is P1 to P2, and this will be rho into V square, but in place of V square you will write C square by R square into R into dr. Clear guys? So integrate this also from R1 to R2. Now simple integration, see rho C square, so this will be P2 minus P1 is going to be rho C square, you can take outside. देखिए अभी लेवल अच्छा लेवल चल रहा है, and I am telling you हर बच्चे के बस की बात अभी नहीं है ये सब प्रॉब्लम्स को हैंडल करना. So a lot of students might run away. Let them run away. Because अभी लेवल बढ़ता चला जा रहा है ना क्वेश्चंस का, तो हर किसी के बस की बात नहीं है हैंडल करना, और वो भी इतने लंबे सेशन को. लेकिन जिसको ज्ञान की प्राप्ति में मजा आ रहा है वो रज के लगा ही रहेगा, क्योंकि उसे पता है कि किस लेवल के क्वेश्चंस यहाँ पर बन रहे हैं. Very good. 202 mm is the correct answer. 202 mm is the correct answer. 202 mm is the correct answer. A lot of you are giving the correct answer. हिमांशु हुड्डा, बच्चे तुमने दिल जीत लिया. ऑलमोस्ट तुम हर क्वेश्चन का सही जवाब दे रहे हो हिमांशु. ऑलमोस्ट तुम हर क्वेश्चन का सही जवाब दे रहे हो, मुझे बहुत खुशी है. ये क्या बचेगा 1 by r cube. उसको ऊपर ले गए तो r टू दी पावर, इसका इंटीग्रेशन क्या आएगा, -3 + 1 डिवाइडेड बाय -3 + 1 एंड लिमिट विल बी फ्रॉम r1 टू r2। सिंपल सा इंटीग्रेशन है, करिए, सारा वैल्यूज पुट कर दीजिए, ठीक है, खत्म कर दीजिए, बूम बम मचा दीजिए। सो यहां से आएगा P2 - P1। सो P2 - P1 आपका आएगा 1984.33, ठीक है। और जब तुम हेड में कैलकुलेट करोगे, इसको हेड में कैलकुलेट करोगे, रोजी से डिवाइड करोगे, तो आपका आंसर 202 समथिंग आएगा, समथिंग आएगा। और मैं तुम्हें बता रहा हूं, ऐसा कुछ क्वेश्चन बहुत एक्सपेक्ट कर रहा हूं, मैं बहुत ज्यादा एक्सपेक्ट कर रहा हूं ऐसा कुछ क्वेश्चन। चलो करो करो, बेहतरीन प्रॉब्लम। अगला प्रॉब्लम आ चुका है बोर्ड पे, अगला प्रॉब्लम आ चुका है बोर्ड पे, अगला प्रॉब्लम आ चुका है बोर्ड पे। करो करो करो, अगला प्रॉब्लम आ चुका है बोर्ड पे, दिया 2 मिनट का टाइम दिया, करो, देखते हैं भाई क्या करते हो तुम लोग। करो करो करो, कम ऑन कम ऑन कम ऑन कम ऑन कम ऑन। अभिनव कुमार, सही है बेटा, बहुत अच्छी बात है। अमन गौर, अभिनव कुमार, संदीप कुमार, बहुत ही शानदार बच्चों, लगे रहो लगे रहो, आज छोड़ेंगे नहीं। आज पूरा का पूरा फ्लूइड मैकेनिक्स हम करके ही यहां से जाएंगे, जितना हमारे मन में है, जितना हमारे मन में। इसीलिए ही हमेशा बोला गया है कि पहले नोट्स को रिवाइज करके ही जीटीक्यू में आए, रिवाइज करके ही जीटीक्यू में आए, नहीं तो आपको बहुत तकलीफ हो जाएगा। साधारण क्वेश्चंस नहीं हैं, अच्छे को प्रॉब्लम्स हैं काफी, और सब गेट लेवल के प्रॉब्लम्स हैं। करें, आ रहा है कुछ आंसर? चलो, जो लोग, whoever is confident, you solve. But the wind velocities were measured over a smooth ground surface 2 meter and 4 meter respectively. Assume the Karman constant and kinematic viscosity. See, he is asking for shear velocity and thickness of laminar sublayer. Can you understand by looking at these words that actually these kind of things comes in the turbulent flow? है ना, these kind of things actually comes in turbulent flow. Do you remember this? Yes, we remember this. So let us use turbulent flows here. Look here. So these are the two conditions which are given to you. If you remember, for turbulent flow, for turbulent flow, tau is equal to rho L square du by dy whole square. Do you remember? I am giving you a hint here that you must replace this L with k into y, and k value is given to be as 0.4 if I am not wrong. Karman constant is 0.4. Yes, it is given to be as 0.4. Wonderful. When you are going to put this, and in the problem the velocity is given with respect to y, so you actually want a relationship between u and v, u and y. And you know, in our classroom we have derived by putting this and integrating twice. You have to integrate twice. Do you guys remember what equation you get? Do you guys remember from our classroom what equation you will get? U is equal to 2.5 of V star log y plus constant, which is c. Do you remember this equation? From this equation only we have written that the velocity profile in turbulent flows is logarithmic. Do you remember this equation? In our derivation this was the first. And what is V star? V star is shear velocity, which is under root of f by 8 into v. Do you remember this? Or in other language, V star can also be written as under root of tau naught by rho, shear velocity. Now it's very simple. Now if you know this equation, by double integrating the shear stress for turbulent flow, just put the values, in this. So the value of 2 is 2.5 of V star log of y is 2 plus constant which is c. Let this equation be equation number 1. What will be the second equation, my dear? Second equation will be u value is 2.3. So this is 2.3 is equal to 2.5 of v star log y at what point? 4 plus constant which is c. See, you can subtract these two equations and find the value of v star. Find the value of v star. Simple. So it was a simple question, just the language was a bit difficult to understand. So you will easily get the value of shear velocity. So shear velocity, when you are going to solve from this, I am already having the answer. You can, wonderful, lot of you are giving the correct answer. Ambrish Yadav, Pooja Meena, Sneha, Huda Bhai, Ashu classes. What kind of, yeah, quite a busy day. Yeah, you know. Quite a busy day, you guys know it. Every day is a busy day, and today is, apart from busy day, it's a knowledgeable day. 1731 meter per second. Wonderful. This will be the shear velocity. What else he is asking? Thickness of laminar sublayer. Array, very simple. How to find thickness of laminar sublayer is delta dash, which is 11.6 nu by v star. 11.6 nu by v star. Just take care of the units. Take care of the units. Centi-Stokes is there. Okay. So to convert this, kinematic viscosity will be 0.145 into 10 to the power minus 2 Stokes. And how to convert Stokes to meter square per second? 10 to the power minus 4. Okay. So therefore, just put the value of kinematic viscosity and v star. You have already found it out. The value of your laminar sublayer will come out to be, anyone with the answer? ये तो हो जाएगा यार, बताओ ये तो हो जाएगा. This, according to my calculation, you can cross verify. This will come out to be 9.7169 into 10 to the power minus 6 meter. साथियों आंसर्स क्रॉस चेक कर लीजिएगा, ठीक है? आंसर्स क्रॉस चेक कर लीजिएगा. गजब, सबने सही आंसर दिया है. सबने सही आंसर दिया है. मैं बहुत खुश हूं. सबने सही आंसर दिया है. फैंटास्टिक, गुड प्रॉब्लम ना, नाइस प्रॉब्लम. कुछ डिफरेंट था. आओ, ये वाला तो करना ही करना है आपको 2 मिनट के अंदर. देखो, ए सुन बच्चे, सुन. ओपन चैलेंज दे रहा हूं इस प्रॉब्लम में. मेरे को एक इसको अब आप चैलेंज की तरह लो, ठीक है? एक बच्चे का जवाब आना चाहिए 2 मिनट के अंदर. टाइम स्टार्ट्स नाउ. द क्वेश्चन इज देयर ऑन द बोर्ड. करो. दिया तुम्हें पूरा मौका दिया, खुली छूट दी. मैं इस प्रॉब्लम के दौरान इंटरफेयर नहीं करूंगा, ठीक है? मैंने आप लोगों को स्वतः खुली छूट दे दी है, बिल्कुल. आप बस मुझे तुरंत इसका आंसर निकाल के दे दें, अगर आप जिंदा हैं तो. हो सकता है भाई इतने लंबे सेशन के लिए लोग तैयार ना हो कि सर तो बस आएंगे, 2-3 क्वेश्चन कराएंगे, सर चले जाएंगे. पर सर को आप जानते नहीं हो. हम तो पूरा फ्लूइड मैकेनिक्स साथ देंगे. GTQ 1 GTQ 2 भी अटेंड करना है बच्चे. GTQ 1 GTQ 2 भी अटेंड करना है, ठीक है? ये मत भूलें. चलो, लास्ट 1 मिनट. घड़ी का काटा तेज चल रहा है. हाई प्रेशर सिचुएशन. ओपन चैलेंज दिया है मैंने. 2 मिनट के अंदर मुझे इसका जवाब चाहिए. लास्ट 53 seconds. Come on guys, come on. काफी उम्मीदें हैं आप लोगों से. आखिरी 30 सेकंड. क्या बात है भाई, कोई जवाब नहीं दे पा रहा है. अमित तिवारी गलत आंसर है. वॉट में आंसर देना है. यूनिट का ध्यान रखना, वॉट में आंसर देना है। लास्ट 10 सेकेंड। टाइम अप, टाइम अप, टाइम अप, टाइम अप। हो गया जी, हो गया, बस हो गया, अभी नहीं। इधर देखो, देखो ये प्रॉब्लम इज इंपॉर्टेंट बिकॉज दीज काइंड ऑफ प्रॉब्लम्स हैव बीन आस्क्ड इन द गेट पेपर, हैव बीन आस्क्ड इन द गेट पेपर। ओके, इसको यहीं पर निपटा देंगे, इसको यहीं पर सॉल्व करेंगे, इस क्वेश्चन को यहीं पर सॉल्व करेंगे। देखो, a pipe carrying water has average height of roughness as इतना, तो average height of roughness को what symbol we show average height of roughness? K, that is 0.48 mm. The diameter of the pipe is इतना, so the, okay, oh my god, the values I have already written, is itna itna itna, all these are given. The power required to maintain the flow. Now why this particular problem is important is because I told you now, this problem, whenever you want to transfer any liquid from one location to another location, this formula is quite important, that is WQ into head loss. WQ into head loss. So in this particular problem it is water, so this will be 9810. Discharge is given to you in the problem, it is 0.6, it is 0.6. So what you need to find out actually, to find the power, what you need to find out actually, it is head loss, it is head loss. So my dear students, no matter whether it is laminar or turbulent, though it is a turbulent flow, the pipe is given to be as rough. If you really want to cross verify, you can, that is your choice. आपका चॉइस है जी। वो कैसे चेक करेंगे? रेनॉल्ड्स नंबर से रो वी डी बाय म्यू कर लो, है ना, या फिर वी डी बाय न्यू कर लो। वेलोसिटी कहां से निकालोगे? डिस्चार्ज दे रखा है, डिस्चार्ज इज एरिया इनटू वेलोसिटी, सो वेलोसिटी कैन बी रिटन एज डिस्चार्ज अपॉन एरिया, है ना। द डायमीटर ऑफ द पाइप इज गिवन, clear guys? Yes, viscosity is given, so you can cross verify with the your Reynolds number also, that it is a turbulent flow in a pipe. So if it is a turbulent flow in a pipe, but it actually doesn't matter, because the head loss formula, no matter whether it is laminar or whether it is turbulent, the formula is FLQ square by 12d to the power 5. The formula is FLQ square by 12d to the power 5. Yes or no? So in this particular problem, length of the pipe is known to you. See here it is 4.5. Calculation you have to do. I will give you hints. Discharge is known to you, diameter is known to you. What is unknown? The friction factor, as it is a turbulent flow and it is rough pipe. Do you guys remember the friction factor for turbulent flow in a rough pipe? It is 1 by root f 2 log base 10 r by k plus 1.74. Plus 1.74. Do you remember this formula? Yes sir, we do remember. But don't commit silly mistake. A lot of students are going to commit silly mistake here. See the radius, so half of the diameter, but this is given in meter, whereas the surface roughness is given in mm. So either you put radius and surface roughness both in meter or both in mm. But don't commit silly mistake that you are putting radius तो सर मीटर में लिए और ये सर mm में लिए, तो गलत हो जाने का ना जी. It is going to get wrong. So from this particular thing you are going to find out the friction factor. Okay. So according to my calculation, you can always cross verify. The friction factor will come out to be 0.01806. 1806 will be the friction factor. Once you put the friction factor in this, you are going to get the value of head loss. You are going to get the value of head loss. According to my calculation, this is 0.01677 dear. 1677 is the head loss. And once you put the head loss in this, see, similar kind of a problem can be asked for laminar flow. Why don't you understand why I have chosen this problem? आप देखिए, मजा देखो. Same problem can be asked for laminar flow through pipe. The only change will be this friction factor, because for laminar flow friction factor you are going to put 64 by Reynolds number. Rest of the things remains the same. Okay, so when you are going to calculate power from this, according to my calculation, it is 98.7. It is 98.7 watt. Okay, this is according to my calculation. Disclaimer, you can always cross check the calculation. The concept is my responsibility. The concept is my responsibility. Very good. Within 2 minutes मुझे इसका आंसर चाहिए. Within 2 minutes मुझे. If you are my student और आप शेर आदमी हो, मुझे इसका जवाब 2 मिनट के अंदर अंदर चाहिए. मुझे इसका जवाब 2 मिनट के अंदर अंदर चाहिए. क्वेश्चन को ध्यान से देख लो, तुम्हारे सामने क्वेश्चन है. एंड इफ यू आर माई स्टूडेंट ना, यू शुड नॉट टेक मोर देन 2 minutes in solving this. You should not take 2 minutes more than solving this. Please remember there is a width also given. Please remember there is a width also given. अभी बच्चा बोल रहा है सर निकालना क्या है, ये देखो ये निकालना है. You have to find out the coefficients A, B, C, D, m dot through QR and drag on the plate. Drag on the plate. If you are my student, within 2 minutes you should give the answer. Within 2 minutes you should give the answer. See, this is the velocity profile. And first of all, in the first part he is asking the value of A, B, C and D. He is asking the value of A, B, C and D. Come on, come on, come on. Boundary layer thickness is 10 mm and it is cubic profile. It is cubic profile. It is cubic profile. Come on, come on, come on. मेरे को बहुत उम्मीद है 2 मिनट के अंदर अंदर इसका जवाब आना चाहिए बच्चों. आज आना चाहिए. इफ यू आर माई स्टूडेंट, आपको क्लास के अंदर एक शॉर्टकट टेबल दी गई है. इफ यू आर माई रेगुलर बैच स्टूडेंट, क्लास के अंदर बहुत मेहनत करी गई है. एक शॉर्टकट टेबल दी गई है आपको, जिसमें लेमिनार की पांचों प्रोफाइल लीनियर, पैराबोलिक, क्यूबिक, साइनोसोडल, पांचों प्रोफाइल. यस यस, वंडरफुल. लास्ट 4 seconds. हो गया जी, हो गया. टाइमर डन, टाइमर डन. चलो बट्टा नीचे आ जाओ. अभी तुम मेरी सुनो, अब छोड़ दो. सुन मेरे लाल, अभी आप मेरी सुनो, ठीक है? हो गया ना, आपने अपने मन की कर ली, अब मुझे अपने मन की करने दो. इधर देखो, सेकंड्स में निपटाएंगे. हालांकि इसको सॉल्व करने में अगर हम इस प्रॉब्लम को सॉल्व करने बैठे तो 10 मिनट यहीं खत्म हो जाएंगे. लेकिन वी ऑल नो द शॉर्टकट एंड दिस इज गेट एग्जामिनेशन. इफ वी नो समथिंग वी शुड एग्जीक्यूट. Don't you understand that? If this is GATE examination, if you know something, you should execute. First of all, what kind of velocity distribution is given? It is cubic. So actually the cubic velocity distribution is given to be as u by u infinity ay by delta plus by delta का square plus अच्छा, just a moment. So this will be u by u infinity is a plus by by delta plus by delta का square plus by delta का cube. So what kind of velocity profile is this? Cubic velocity profile. If you know how to solve this from boundary condition, chalo let us revise the boundary condition. At y is equal to 0, u is equal to 0. At y is equal to delta, u is equal to u infinity. At y is equal to delta, the du by dy is equal to 0. And at y is equal to 0, the double derivative of u with respect to y is equal to 0. These are necessary conditions. This is coming from Prandtl's boundary layer equation. And what is next? At y is equal to delta, the double derivative of u with respect to y is equal to 0. So these are the boundary conditions. But here how many unknowns are constants are there? 1, 2, 3 and 4. Already told to you in the classroom. What is the shortcut? I made you remember the profiles. I made you remember the profiles. Can anybody tell me, because most of you have given the correct answer, you might be my regular batch student. So u by u infinity cubic velocity profile is 3y by 2 delta minus y cube divided by 2 delta ka cube. So if you remember that our cubic velocity profile is this, automatically without solving you can give the answer in fraction of second that the value of A will be 0, the value of B will be 3 by 2, the value of C will be 0 and the value of D will be minus 1 by 2. Because you can see there is a term of y by delta in cube. So the first A is 0 and the square constant is 0. So how many of you got the same answer? How many of you got the same answer? Arey wow, I am so happy. Lot of you gave the same answer. Acha, what is the next thing? Find the mass flow rate through QR. ये भी कोई क्वेश्चन होता है जी? ये भी कोई क्वेश्चन होता है क्या? Do you remember that for this particular velocity profile, that the cubic velocity profile, do you guys remember the value of delta star for cubic? I have given you a summary table. Do you remember that? From the summary table, if you will see, the value of delta star for cubic velocity profile is 3 delta by 8. It is 3 delta by 8. Then how to find out the mass? Let me use a different color. ये भी कोई क्वेश्चंस होते जी? आप देखो कितना बड़ा क्वेश्चन. अगर हम इसको सॉल्व करने जाएं गेट के पेपर में, अगर हम इसको सॉल्व करने जाएं कितना टाइम कंज्यूम हो जाएगा, क्योंकि पहले आप इन निकालोगे, फिर यहाँ छोटा सा स्ट्रिप लोगे, उसको इंटीग्रेट करोगे, तब जाके उसको उससे सब्सट्रैक्ट करके तब आपका वो आएगा. बट एवरीबडी नोज दैट द मास फ्लो रेट पासिंग थ्रू डेल्टा स्टार इज एक्चुअली द मास फ्लो रेट पासिंग थ्रू QR. So mass flow rate passing through QR will be mass flow rate through delta star, that is rho u infinity delta star cross B, where B is the width of the plate. Don't miss out on the width of the plate. Okay, so rho value is how much? Rho is 1. U infinity is how much? Is 10 into delta star is 3 by 8 into delta star is and delta is 10 mm, so 10 into 10 to the power minus 3 into depth of the plate is 3. Depth of the plate is 3. Are you getting? How? जल्दी से आंसर बताओ इसका कितना है? जल्दी से आंसर बताओ इसका कितना है? 0.112. देखो देखो कुछ नहीं करना, आप लंबा मेथड लगा ही क्यों रहे हैं? ये गेट का पेपर है. Time is very important. Time is very important. So this will be 0.112 kg per second. आप हमेशा क्रॉस वेरीफाई कर सकते हो. Question is still not over. Question is still not over. What is the next thing? Drag on the plate. Drag on the plate. Already told to you in the classroom the shortcut. How to find the drag on the plate? It is the momentum thickness. What is the momentum thickness for your cubic velocity profile? 39 delta by 280. And how to find the drag on the plate? Drag on the plate is actually the momentum passing through theta. Is the momentum passing through theta, which is going to be rho u infinity square into theta cross B. Into theta cross B. So rho is 1 if I am not wrong. Yes, rho is 1. U infinity is 10. So this is 10 cos square into theta. Theta कितना है मेरे लाल? 39 by 280 into 10 to the power 10 into 10. So it is 10 into 10 to the power minus, yes, 10 into 10 to 10 into 10 to the power minus 3 into depth of the plate is 3. जल्दी बताओ what is drag on the plate? छा जाओ दुनिया पे, बिल्कुल छा जाओ. देखिए आप, अगर हम इसे नॉर्मल कन्वेंशनल सब सॉल्व करने लगते, लग जाते 10-15 मिनट. ठीक है, वो तो मैं इतना आपके साथ वार्तालाप कर रहा हूं, दैट्स व्हाई इट हैज टेकन सो मच ऑफ टाइम. नहीं तो सेकंड भर में आंसर है ये. बताओ व्हाट इज द आंसर? 0.4178. This will be 0.4178 Newton is our answer. You are giving this answer, always cross verify. Concept giving is my. I think you after this particular problem you should dance. You should dance. Huh? Why? This shows you the importance of that summary table which I have given you. This shows the importance of the summary table which I have given you. चलो एक क्वेश्चन ब्लॉशियस से कर लेते हैं. So this is the question on ब्लॉशियस. Again I am giving you 2 minutes of time. Again I am giving you 2 minutes of time. Come on guys. Again I am giving you 2 minutes of time. Very good. Very good. Abhinav Kumar, Nikhil Kanojia, Aryan, Archik, Madhuri, Anurag, Zahir Sheikh, Gautam Shrikant. You can refer to class note. Abdul Zahir Sheikh. You can refer to class notes. It's there in class notes. Come on. 2 minutes. 2 minutes to solve this problem. Karo ji, karo. Aa jao. Come on. We should always enjoy science. Science is always there for enjoyment. बताओ भाई बताओ, ज्यादा जवाब आने चाहिए. ज्यादा जवाब आने चाहिए. चलो. Last 27 seconds. Still no one is giving me the answer. Still no one is. अबे किसी पार्ट का तो आंसर बता दो. कुछ तो निकाल रहे होगे. किसी पार्ट का तो आंसर बता दो. किसी पार्ट का तो आंसर बता दो. यस, काफी बच्चों ने सही जवाब दिया है. 12.99 mm या 13 mm इज द करेक्ट आंसर. समय समाप्त हो गया है भाई, घंटी बज गई है. आओ इसको रीसेट कर लेते हैं. देखो क्वेश्चन सॉल्व करने में कुछ नहीं है, बच्चों वाला सवाल है, लिटरली बच्चों वाला सवाल है. ये देखो मैं एक्सप्लेन करता हूं. यही तो है गेट की. आपको यू हैव टू बी वेरी फास्ट, स्ट्रिक्टली ऑन योर टोज. ये देखो, सो देयर इज दिस प्लेट इज देयर, रेक्टेंगुलर प्लेट इज देयर, whose dimensions are given to be 15 centimeter and 45 centimeter, and from here the flow is coming in. Now how do you got to know that the plate is kept in the flow just like this? Because it is mentioned that the flow is along the longer side of the plate. So isn't it the 45 centimeter the longer side of the plate? This means the flow is happening like this over the plate. The flow is happening like this over the plate. Now do you guys remember the first edge over which this is going to, this is known as leading edge of the plate. This is going to be leading edge of the plate. And this is known as what, bacha? This is known as trailing edge of the plate. This is known as trailing edge of the plate. Now see, free stream velocity, that is u infinity, is given to you. Kinematic viscosity of the fluid is given, and the density of the fluid is given. He is asking boundary layer thickness at the trailing edge of the plate. See my dear students, in this particular problem the velocity distribution is not given. If velocity distribution is not given, then you have to use the Blasius equation. There is no other way out. But to see, for Blasius, for applying Blasius, you should know now whether our flow is laminar or whether our flow at the wherever he is asking is turbulent. So he is asking at the trailing edge of the plate. So trailing edge of the plate means this. Trailing edge of the plate means this. So if you want to find out trailing edge of the plate, all the distances are measured from the leading edge and showed by the symbol x. So x will be 0.45. X will be 0.45 meter. So first step will be find out whether the flow at the trailing edge of the plate is laminar or turbulent. So find out whether it is laminar or turbulent. Let us go for Reynolds number at trailing edge, that is x equal to 0.45. How to find Reynolds number? U infinity into 0.45, that is x, divided by kinematic viscosity. So when you are going to find this Reynolds number, you have to cross verify, of course. This will come out to be 3 into 10 to the power 4 according to my calculation, which is less than the critical Reynolds number. And if it is less than the critical Reynolds number, this means the boundary layer at the trailing edge of the plate is still what, bacha? It is laminar. It is laminar, and once it is laminar, you need to find out the boundary layer thickness at the trailing edge means x equal to 0.45. What is the Blasius equation? Fx divided by under root of Reynolds number. So Reynolds number at the trailing edge means x equal to 0.45. Already you have found out this Reynolds number. X value you have to put 0.45. So when you are going to calculate this, this will come out to be 1.3 centimeter. This will come out to be 1.3 centimeter. What else you want? Drag force on one side of the plate. See, for finding the drag force, you need the value of CD. Now, what is the value of CD? Coefficient of drag. According to Blasius, for laminar boundary layer over the plate, the value of CD is approximately 1.328 divided by under root of Reynolds number at the trailing edge of the plate, which you have already found out 3 into 10 to the power 4. So when you are going to solve this, you are going to get the value of CD from here. And how to find drag force? Drag force will be CD into half rho A U infinity square. My dear students, CD you will find from here. Nice problem. See the quality of the each and every problem. See the quality of each and every problem. It's not about the quantity, it's about the quality and how much teacher is struggling for you guys even after GTQ1 and GTQ2. अब देखो GTQ1 भी 3.5 घंटे समथिंग, GTQ2 भी इतना ही देरी का. अब देख रहे हो वहां कितना कंटेंट ऑलरेडी जा चुका है, बट हम कुछ अलग ही फ्रेम ऑफ क्वेश्चंस को डिस्कस कर रहे हैं यहाँ पर. बट इसका मतलब ये नहीं है कि GTQ1 और GTQ2 आपको नहीं देखना है. यू हैव टू सी GTQ1 and GTQ2. So all the well area of the plate you know, rho you know, everything you know. Just multiply everything. Very good. All of you are, a lot of you are giving the correct answer. This will come out to be 8.61. 8.61 Newton. 8.61 Newton. Very good. Now how, still the question is not over. Next he is asking for wall shear stress at the trailing edge of the plate. To find the wall shear stress, what you need to do beta? You have to find out the value of CFX. That is the local friction coefficient. Local friction coefficient. Now what is the local friction coefficient or the skin friction coefficient? Is half of CD. Do you know the relation or not? Do you know, in our classroom I have told you that CD is twice of the skin friction coefficient at the trailing edge of the plate. At the trailing edge of the plate. If this is the value of CD at the trailing edge of the plate, then CFX will be half of this. Khatam. CFX will be half of this. If you know Blasius, this will be 0.664. 0.664 divided by under root of Reynolds number at the trailing edge of the plate. And you can find wall shear stress from here. Wall shear stress will be CFX, जो भी आपने निकाला x equal to L पे, multiplied by half rho U infinity square. हाँ भाई, किसी का आंसर आ रहा है? 63.8. गजब ही ढा दिया. प्रतिभा, अमन, मोहम्मद सुल्तान, सुमित, निखिल, विनय, गौरव. Beautiful beta, all of you are giving the correct answer. So the wall shear stress at trailing edge of the plate means x equal to 0.45. 0.45. कितना आंसर आ रहा है बच्चों? 63.8 पास्कल. 63.8 पास्कल. ठीक है, चलो आगे बढ़ते हैं. This question is your homework. I will give you hint. This question is your homework. Read the question. This question is your homework. Read the question. प्रतिभा, लोकल स्ट्रेस देखो, आपको ट्रेलिंग एज पे स्ट्रेस कैलकुलेट करना है, तो आपको एक पर्टिकुलर पॉइंट पे कैलकुलेट करना है. ठीक है प्रतिभा जी. राज बाबू जैन, थैंक्स अलॉट डियर, थैंक्स अलॉट. आप ही लोगों के लिए इतना मेहनत कर रहा हूं मैं, इतना स्ट्रगल कर रहा हूं मैं, एंड आई एम रियली वेरी हैप्पी दैट यू गाइज आर स्टिल विद मी. नहीं तो जी क्वेश्चंस का लेवल देखकर बहुत लोग भाग गए होंगे जी. नहीं झिलता है बहुत बच्चों से. आओ इधर देखो, मैं हिंट दूंगा आपको. इस क्वेश्चन के लिए होमवर्क है आपका. इन अ लेबोरेटरी एक्सपेरिमेंट एन ऑरिफिस ऑफ डायमीटर इतना 15 mm इज इंस्टॉल्ड इन 25 mm डायमीटर पाइप, और आपने दो जगह पे प्रेशर टैपिंग लगाई है ना, कनेक्टेड टू अ वर्टिकल मरकरी मैनोमीटर. द डिस्चार्ज इज ऑब्टेन्ड बाय मेजरिंग द राइज इन अ वाटर लेवल इन अ टैंक, जिसका साइज दे रखा है. ठीक है, और आपको रीडिंग भी दे रखी है. ये प्योर एक क्वेश्चन है. द लेबोरेटरी एनालिसिस ऑफ ऑरिफिस मीटर वी डू लाइक दिस. द लेबोरेटरी एनालिसिस ऑफ ऑरिफिस मीटर वी डू लाइक दिस, इफ यू रिमेंबर. ओके, चलो लेट अस सॉल्व दिस. So I will give you hints. See, for example, if this is your pipe is something like this, then if you install an orifice meter something like this, so this is the orifice meter. I'm just giving you hint. So the fluid is going to flow something like this. The fluid is going to flow something like this, form a vena contracta, and that fellow is saying that you are installing a pressure device just before and after the orifice, So for example, if you take this as 1 and if you take this as 2, then everybody knows it is given in the problem. D1 is how much? D1 is 25 mm. D1 is 25 mm. If you are confident, अगर आप confident हो आप करो, करते चले जाओ. अगर आप कॉन्फिडेंट हो आप करते चले जाओ. ठीक है, मैं आपको रोकूंगा नहीं. और D2 कितना है बेटा? ऑरिफिस का डायमीटर 15 mm दे रखा है. इट इज गिवन टू बी एज 15 mm. ओके, नेक्स्ट ही सेज कनेक्टेड टू अ वर्टिकल मैनोमीटर दिस एंड दिस. तो भैया ये मैनोमीटर है, बट एवरीबडी नोज हेयर the pressure is going to be more, here the pressure is going to be less. So this is how the manometer is going to be there, and this is a mercury manometer, and let the deflection in this manometer is some x. अच्छा, ये यहाँ से whatever water is coming out of this na is collected in a square tank. Whatever water is coming out from this pipe na is collected in a square tank having the sides of, it's a beautiful problem again, 30 centimeter cross 30 centimeter. So the sides are 30 centimeter cross 30 centimeter, 30 centimeter cross 30 centimeter. So water यहाँ पर जमा हो जाएगा, वाटर यहाँ टैंक के अंदर जमा हो जाएगा, और वो कितना पानी लेवल राइज कर रहा है? 120 mm in 5 seconds. So the height rise in this is 120 mm in t is equal to 5 seconds. So can you find out the value of discharge from here? Of course, discharge is volume per unit time. So volume is going to be 120 into 10 to the power minus 3 into 0.3 into 0.3 divided by 5. So this is how you can find the discharge passing through this. Clear guys? Once you find out the discharge passing through this, what you need to find? Oh, you have to find the coefficient of discharge. You have to find out the coefficient of discharge. So how will you find the coefficient of discharge? Once you have found out discharge, discharge will be CD A1 A2 under root of 2GH divided by under root of a1 का. I am just giving you hint to this problem, you have to solve. I am just giving you hint to this problem, you have to solve. Fantastic problem. So see, in this particular problem, a1 is known, a2 is known, diameters are known na. a1 is known, a2 is known. Okay, so a1 is known, a2 is known, 2 is known, g is known, h you have to find out. And what is h beta? What is h? P1 minus P2 by W. And how will you find P1 minus P2 by W? Apply manometry between 1 and 2. So if you remember from our classroom discussion, this is going to come out to be x sm by s minus 1. X sm by s minus 1. So my dear students, already I think, yes, deflection is given. See here, deflection in the manometer is given. माइंड ब्लोइंग प्रॉब्लम यार, मैं इसको ऐसे ही सोच रहा था, बट गर्दा छुड़ा दिया जी प्रॉब्लम ने. मैं इसको ऐसे ही सोच रहा था कि होमवर्क कर लोगे आप, बट आप एक मतलब जस्ट लुक एट द ब्यूटी. किसी भी प्रॉब्लम को आप ऐसे छोड़ नहीं पा रहे हो, सब जबरदस्त प्रॉब्लम है. तो यहां से भाई यही तो एच है तुम्हारा, ठीक है. डिफ्लेक्शन तुम्हें दे रखा है, एसएम तुम्हें पता है, एस तुम्हें पता है, क्या एच आ जाएगा? अगर एच आ जाएगा तो इसको इसके अंदर पुट करो, डिस्चार्ज आपको पता है, और सीडी की वैल्यू का आनंद उठाओ. व्हाट अ प्रॉब्लम. सीडी की वैल्यू का आनंद उठाओ. एक बारी कमेंट बॉक्स में टेल मी वेदर यू आर एंजॉयिंग लाइक एनीथिंग और नॉट. Just tell me in the comment box whether you are enjoying like anything or not. Beta, next problem has come on board, and let me tell you, I want the answer to this problem in 2 minutes. I want the answer to this problem in 2 minutes. But पहले एक बारी comment, चलो मैं stop कर रहा हूँ टाइमर stop कर रहा हूँ. एक बारी comment box में एक बच्चा जो अभी तक है, tell me in the comment box, are you enjoying the beauty of fluid mechanics or not with Pathak sir? Look at the beauty of fluid mechanics with Pathak sir. Wonderful. चलो टाइमर शुरू कर दिया, बहुत हो गया. 2 मिनट के अंदर जवाब चाहिए इसका. 2 मिनट के अंदर जवाब चाहिए इसका. चलो 2 मिनट के अंदर जवाब चाहिए इसका. बेटा ये सेशंस झेल पाना हर किसी के बस की बात नहीं है. पहले ही आपको आगाह कर दिया गया था कि लंबा सेशन होने वाला है. बिकॉज आप क्वालिटी देखो ना, क्वालिटी देखो. आपको सॉल्व भी करने का पूरा समय दे रहा हूं मैं, आप क्वालिटी देखो. जल्दी जवाब बताओ भाई. आई एम वेटिंग फॉर योर रिप्लाईज. कम ऑन. लास्ट 1 मिनट. भाई इसका जवाब तो बता दो. चलो काफी लोग सही जवाब दे रहे हैं. गौतम, श्रीकांत, तारा, अखिलेश, तरुण, ऋतिक, सागर, रोहित, शशांक, अमरजीत, अर्चिक, हिमांशु, ब्रह्म कुमारी दास, आयुष, रोहित. दिल जीत लिया बच्चों आज तुमने. जो बच्चे अभी तक टिके हुए हैं, दिल जीत लिया बच्चों आपने. 40 सेकंड और घड़ी का काटा दौड़ रहा है. कृपया करके जवाब बताएं. बोलिए. फर्स्ट का आंसर बी है. समय समाप्त. फर्स्ट का आंसर बी है, ठीक है. फर्स्ट का आंसर बी है, ठीक है. आओ सेकंड भर में खत्म करेंगे इसे. सेकंड भर में खत्म करेंगे. ये कोई सवाल होता है? इधर देखो, सेकंड भर में खत्म है. ये देखो, आपसे बोल रहा है फाइंड द प्रेशर एट द बॉटम, पहले पार्ट में यही तो बोल रहा है, फाइंड द प्रेशर एट द बॉटम। सो प्रेशर एट द बॉटम, प्रेशर एट द बॉटम, यूनिट क्या दे रहा है बेटा, यूनिट का ध्यान रखना जरूरी है, बार में पूछ रहा है, ठीक है कोई बात नहीं, बार में पूछ लो। सो प्रेशर एट द बॉटम, प्रेशर एट द बॉटम क्या होगा, गैस का प्रेशर प्लस ऑयल का प्रेशर प्लस पानी का प्रेशर। सो भाई बेटा ये तो 2 इंटू पास्कल में सॉल्व करते हैं, फिर बार में चेंज कर लेंगे। 2 इंटू 10⁵ गैस प्रेशर प्लस ऑयल का प्रेशर कितना होगा, 800 इंटू जी का वैल्यू कितना लेने को कह रहा है, जी के वैल्यू के बारे में उसने कुछ नहीं कहा है, तो हम 9.81 ही लेकर चलेंगे, मल्टीप्लाइड बाय हाइट इज 1, इसमें ऐड करेंगे किसका, पानी का प्रेशर। बेटा तुझे बॉटम पे निकालना है तो ये पूरी हाइट लेनी पड़ेगी। सो दिस इज गोइंग टू बी 10⁻³ इंटू 9.81 इंटू हाइट इज कितना, 1 + 1 + 1 इज 3। तो जब आप इसको सॉल्व करेंगे मेरे लाल, इसको सॉल्व करेंगे तो 2.37 बार आएगा, 2.37 बार आएगा आपका जवाब। तो अपना आंसर आ गया ये बी बॉम्बे। दूसरे का निकाला क्या किसी ने, दूसरे का निकाला क्या किसी ने, नहीं निकाला फंस गए। क्या सर जी, क्या सर जी, मेरा स्टूडेंट होके इतना टाइम लगाना ही नहीं सर जी। ये गेट बताओ प्लेन सरफेस है कि कर्व सरफेस है, प्लेन सरफेस है। अगर ये गेट प्लेन सरफेस है तो भैया इसके ऊपर लगने वाला फोर्स तुम्हें निकालना है, तो इसके ऊपर लगने वाला फोर्स ओवर एनी प्लेन सरफेस, हाइड्रोस्टैटिक फोर्स ओवर एनी प्लेन सरफेस इज प्रेशर एट सेंट्रॉइड of plane surface multiplied by the area of the plane surface। पढ़ाया है क्लास के अंदर। भाई 2-3 टेक्निक हो सकती है। आप देखो, एक तो प्रेशर प्रिज्म है, प्रेशर प्रिज्म में टाइम लगेगा, हियर इन द टेक्निक ऑफ प्रेशर प्रिज्म टाइम लगेगा, ये सबसे आसान है, प्रेशर एट द सेंट्रॉइड ऑफ द प्लेन सरफेस मल्टीप्लाइड बाय एरिया। तो आपको बेसिकली इस लेवल का प्रेशर निकालना है, क्योंकि इसका सीजी यहां पर होगा, तो ये डिस्टेंस कितना है बच्चे, 0.5। सो प्रेशर एट द सेंट्रॉइड मल्टीप्लाइड बाय एरिया करो भाई। सो फोर्स विल बी प्रेशर एट सेंट्रॉइड और सीजी ऑफ द प्लेन सरफेस मल्टीप्लाइड बाय एरिया। आजा मेरे लाल, व्हाट विल बी द प्रेशर एट द सेंट्रॉइड, pressure at the centroid will be 2 into 10⁵ plus oil का pressure, that is 800 into 9.81 into height is 1। उसमें ऐड करेंगे पानी का प्रेशर, लेकिन पानी का प्रेशर यहां तक का, क्योंकि बेटा ये है इसका सेंटर ऑफ ग्रेविटी, तो यहां तक का प्रेशर निकालेंगे। मतलब कितनी हाइट, 1 + 0.5 इज 1.5। सो दिस इज 10⁵ इंटू 9.81 इंटू 1.5। ठीक है, ये हो गया प्रेशर एट द सीजी मल्टीप्लाइड बाय द एरिया ऑफ द गेट। बताइए बच्चे, अरे देखो परपेंडिकुलर टू द पेपर 1 मीटर वाइड दे रखा है, तो भाई ये सिर्फ हाइट ही बची, तो मतलब 1 ही हो गया, 1 ही हो गया। तो यहां से आपका फोर्स आ जाएगा, आपका फोर्स आएगा 2.23, आपका फोर्स आएगा 2.23 इंटू 10⁵ न्यूटन। देखा, आंसर इज सी चेन्नई, आंसर इज सी चेन्नई। बहुत खुश हूं यार। देखो, हर टेक्निक का अपना एक यूजेज है। अब यहां पर मुझे पता है प्रेशर प्रिज्म लगाऊंगा निकल जाएगा। प्रेशर प्रिज्म कैसे बनेगा, ये देखो यहां पर एरो, यहां पर बनेगा, इसको ज्वाइन करेंगे, वॉल्यूम ऑफ द प्रेशर प्रिज्म निकालेंगे, वहां से भी आ जाएगा। लेकिन भाई जो आसान टेक्निक है उसको लूंगा ना, उसको लूंगा। देखो ये वाला प्रॉब्लम बहुत अच्छा है, दिस इज अ नाइस प्रॉब्लम, दिस इज अ जेन्युइन प्रॉब्लम, दिस इज अ नाइस प्रॉब्लम, दिस इज अ जेन्युइन प्रॉब्लम। फिर से 2 मिनट का समय दे रहा हूं, फिर से 2 मिनट का समय दे रहा हूं। ए सुनो भाई, एक बारी कमेंट बॉक्स में बता दो थके तो नहीं हो। अगर देखो, आई एम हाईली एक्साइटेड, आई एम हाईली एक्साइटेड। मुझे तो भाई मेरा तो मन ही है आपको बेस्ट पॉसिबल देना, बट सोचने समझने वाली बात यह है वेदर यू आर इक्वली एक्साइटेड और नॉट। कहीं थक वक्त तो नहीं गए, छोड़ दें, खत्म करें, या और सवाल चाहिए, मजा करें? बताओ बताओ बताओ, कमेंट बॉक्स में बताओ, फिर ही टाइमर शुरू करूंगा। फ्री टाइमर शुरू करूंगा, एक बारी कमेंट बॉक्स में बता दो, शुड वी कीप ऑन कंटिन्यूइंग? और चाहिए, अच्छा जी, और चाहिए। चलो टाइमर शुरू हो गया है, घड़ी का काटा शुरू, चलो जल्दी करो, जल्दी करो, अच्छा प्रॉब्लम है। नहीं भाई, हो सकता है ना किसी को भूख लग रही हो, किसी को वॉशरूम जाना हो, किसी को कुछ जाना हो। नोटिस कीजिएगा, आपका टीचर भी इक्वली स्ट्रगल कर रहा है आपके साथ। नहीं होता है, मेहनत करते टाइम ही शरीर में कंपन फील होने लगता है, वॉशरूम आने लगता है, भूख लगने लगती है, सवालों से मन उब जाता है। सब पढ़ाई के टाइम ही तो होता है। इसे इसे पढ़ाई सिंड्रोम कहते हैं। इसे पढ़ाई सिंड्रोम कहते हैं। इसे पढ़ाई सिंड्रोम कहते हैं। आम दिनों में पिक्चर देखते टाइम या खेलते कूदते टाइम, इधर उधर यारी दोस्ती करते टाइम ये पढ़ाई सिंड्रोम नहीं नजर आता है। ये पढ़ाई सिंड्रोम केवल कुछ अभिन्न परिस्थितियों में आता है जब मेहनत करने की बात पड़े। आखिरी 30 सेकंड, कम से कम डायग्राम ही खुद बनाने की कोशिश कर लो। 1.57 सुमित पटेल, पहला जवाब दिया है सुमित पटेल ने और बिल्कुल करेक्ट जवाब दिया है। आई एम हाईली इंप्रेस सुमित पटेल। रोहित कुमार, गजब बच्चों, तुम तो छा गए जी। अब अभी कौन रोक रहा है जी आपको गेट के पेपर में? अभी कौन रोक रहा है जी आपको गेट के पेपर में? ऋतिक रस्तोगी, हिमांशु हुडा, भाई बच्चों तुम्हारे लिए मैं 10 बजे तक खड़ा हो जाऊंगा यार। मजा कर दिया तुमने इसका जवाब देकर। आओ मैं पढ़ाता हूं तुम्हें। 2 सेकंड का सवाल है ये, हार्डली 2 सेकंड्स का क्वेश्चन है ये। एन इंक्लाइंड वेंचुरीमीटर इज कनेक्टेड टू अ इन्वर्टेड यूट्यूब। फर्स्ट ऑफ ऑल दो चीजों पर नोटिस करो, एक तो वेंचुरीमीटर इंक्लाइंड है और दूसरा जो मैनोमीटर उस पर लगा रखा है वो अपना नॉर्मल यूट्यूब वाला नहीं है, इन्वर्टेड यूट्यूब वाला है। क्या तुम लोगों को याद है कि इन्वर्टेड यूट्यूब में मैनोमेट्रिक फ्लूइड की डेंसिटी फ्लोइंग फ्लूइड की डेंसिटी से कम होती है? In our inverted YouTube manometers, the density of the manometric fluid is lesser than the density of the flowing fluid, है ना? The flowing fluid in the venturimeter is water, okay. The manometric fluid is inverted YouTube oil, so okay, this is the manometric fluid. Cross sectional area at the inlet and at point 2 is given. If the discharge is given, he is asking deflection in the manometer. Excellent problem. आओ खत्म करते हैं सेकंड भर में. So let me make a rough diagram. I am making a really very rough diagram बेटा, है ना? क्योंकि गेट के पेपर में सुंदरता गई तेल लेने भाड़ में। भाई अपने को जवाब से मतलब है, अपने को जवाब से मतलब है। सो सबसे पहली चीज तो इंक्लाइंड है, इसको 1 लिए, इसको 2 लिए, ठीक है। और अच्छा भैया मैनोमीटर ऐसे नहीं लगाए हैं जी, इन्वर्टेड वाला लगाए हैं जी, इन्वर्टेड वाला लगाए हैं ना भैया जी। सो अगर इन्वर्टेड वाला लगाए हैं तो इस वाले लिम में ऊपर की तरफ होगा, इधर नीचे की तरफ होगा, क्योंकि यहाँ का प्रेशर ज्यादा है ना। और ये जो लिक्विड है इसकी डेंसिटी है 800 kg पर मीटर क्यूब। मैं नहीं, वो खुद कह रहा है। और आपको ये डिफ्लेक्शन निकालना है, यू हैव टू फाइंड आउट द वैल्यू ऑफ दिस डिफ्लेक्शन। अभी क्वेश्चन समझ में आ गया? और जो फ्लूइड फ्लो कर रहा है उसका डेंसिटी है 1000 kg पर मीटर क्यूब, और डिस्चार्ज भी दे रखा है, A1 A2 भी दे रखा है। Do you guys remember directly? Of course you have to apply jumping jack. Start from here, P1 by W plus minus Y minus X, SMX by X. Do you remember our classroom discussion? But no need to do that, because you already know, already in your notes you will find that for inverted YouTube manometer, this H here, what is going to be H? H is going to be the piezometric head difference, na? because this is inclined na, P2 by W plus Z2 है, and this is X 1 minus Sm by S. In this particular case, rho m by rho. Khatam, the question is over. How the question is over? How the question is over? Just look. Everybody knows that discharge, is there any CD coefficient given? Is there any CD coefficient given? No, it is not given. So it is ideal case. A1, A2 under root of 2GH divided by under root of A1 ka square minus A2 ka square. My dear students, A1 is known, A2 is known, 2 is known, G is known, A1 is known, A2 is known, discharge is known. Can you see? Discharge is known. If everything is known, from here can you find the value of H? From here can you find the value of H? Can you find out the value of H? Once you find out the value of H, you put it in this. Rho m is known, rho is known. Khatam. Can you find out the value of X, which is the deflection? Yes, 1.5763. So this is the deflection, and this answer will be 1.5763. I think it is in meter. I think it is. Yes, very good. A lot of you have given the correct answer. Pratibha, Gaurav, Shivam, Anand, Prakhar, Abhinav, Akhilesh. शानदार छात्रों, look at the quality of the question. बेंचुरी है, सब चीज है, इन्वर्टेड है, पर आपको देखो, there can be two ways. आप पूरा जंपिंग जैक लगा के भी करोगे तो यही आना है. चलो नेक्स्ट क्वेश्चन. नाउ फॉर दिस ईयर सी देखिए, this question I have kept at the last, towards the last of today's GTQ. The reason is because I only wanted that only the serious students should get this question. So all those students, how many are live? Approximately 200 plus are live. Approximately 200 plus are live. So if 200 plus are live, these are serious students who have supported me for the last 3 hours. My dear students, this question I feel is very important for this year. This is a question of your Kuti flow. This is your question of Kuti flow. Okay. So if you are my student, I have already told you in QRC also. Consider a steady, fully developed flow of liquid between two horizontal plates. Distance is itna. One of the plate is fixed and another plate is moving at a speed of itna. What is the magnitude of pressure gradient? So he is asking for pressure gradient. See, if one plate is stationary and one plate is moving, and if pressure gradient is present, this is known as complex Kuti flow. This is known as complex Kuti flow. But if one plate is stationary, another plate is moving, and pressure gradient is not present, this is known as simple Kuti flow. But this one is the complex Kuti flow. He is asking what should be the pressure gradient such that the net flow is 0, and also the dynamic viscosity of liquid is given. My dear students, these are the formulas of Kuti flow, already told to you in the classroom. You can note down in your register. These are very, very important. See, laminar flow through circular pipe, laminar flow between two fixed parallel plate, laminar flow between two parallel plates when one plate is stationary and one plate is moving is known as Kuti flow. Already in the QRC, quick revision course of Made Easy, I have given you these formulas. In some of the regular batches also I have given these formulas, but today I'm discussing in a general manner on YouTube. Chalo aao. So it is my humble request that you remember. So this is the velocity. See, and one more important thing, in case of complex Kuti flow, the maximum, see this kind of velocity profile you are going to get. The maximum velocity you don't get at the center. You don't get at the center, you get at a distance of y. Which formula is this? Whose formula is this? Okay, so kindly remember. So this is the velocity distribution. This is the formula for average velocity. All the notations are written. This is the formula for shear stress distribution in a complex Kuti flow where pressure gradient is there, and most of the time this is the most important problem. Okay, so you know, yes, someone has said it correctly. Someone has Ajay Bakare has pointed out correctly that this question was asked in 2022 XC paper. So today's session is valid for civil engineering, mechanical engineering and XC. So see, he is asking such that the flow rate is 0. He is asking what is the condition he is giving? Net flow through the plate is 0. See, net flow through the plate is going to be 0. Net flow through the plate is going to be 0 when the average velocity is going to be 0. So what is the formula for average velocity? This is the formula for average velocity. This is the formula for average velocity. So V average is equal to U by 2 is U by 2 minus 1 by 12 mu into del P by del X into H square. Del P by del X into H square. My dear students, this is the value of H, okay, and this is the value of U. Just put all the values and put V average as 0. Once you do this, you will get the value of del P by del X. Anyone in the classroom, what is the value of del P by del X? It will come out to be 375. It will come out to be 375. It will come out to be 375. Come on guys, come on. It will come out to be 3. Very good, Himanshu, Shrimani, Purab, Sneha. Wonderful. Dil hi jeet liya bachchon. Parantu, all these formulas note down in your notes, in your register. This will be helpful. Chalo, next problem. Again, I feel that this is a very good problem. So I am again giving you 2 minutes of time. Read the problem and try to solve. Again, I feel that this is a very good problem. Again, I feel this is a very good problem. I am giving very good. अरे वाह, सबने सही जवाब दिया. चारू दत्ता पाटिल, शिवम, रोहित, अम्बरीश, स्नेहा, पूर्णब, श्रीमणि, अभिनव, ब्लैस्की, सुमित पटेल. गजब, आप लोग तो जी बिल्कुल अभी खो गए हैं फ्लूइड मैकेनिक्स में जी. अभी आप खो गए हैं जी फ्लूइड मैकेनिक्स में जी. चलो कर दो भाई, कर दो, आ जाओ, जल्दी जवाब दो. इसका जवाब नहीं तो कम से कम रीड कर लो. रीड कर लो. अच्छा प्रॉब्लम है. देखो, फ्लो in flow through pipe I have chosen only one problem. But that one problem is not quality problem. Yes, wonderful. फैंटास्टिक. आओ चलो करें. 10 सेकंड, 5 सेकंड, 4 सेकंड, 3, 2, 1, समय समाप्त. आओ चलो. एटलीस्ट इतनी देर में रीड तो कर ही लिया होगा, और रीड कर लिया होगा तो ट्राई कर लो. वाटर इज पंप थ्रू अ 600 mm डायमीटर पाइप with head loss of इतना. ठीक है. It is intended to reduce the power consumption by laying another pipe in parallel of another pipe of parallel of appropriate diameter led by the side of the existing pipe. So the beautiful point is you are not changing the existing pipe. So existing pipe, the length and diameter remains the same. But the new pipe that you are writing now is of the same length, and same friction factor, but the diameter will be different. Beautiful. To reduce the head loss by 10 meter but still delivering the same discharge jointly through both the pipes, the diameter of this additional pipe is rocking question है जी, कोई रोक ही नहीं सकता इसको रॉक करने से। इधर आओ, मैं देखते हैं, हम सॉल्व करने का चेष्टा करते हैं इसको। आओ, सबसे पहली बात तो है देयर वाज अ सिंगल पाइप हैविंग 600 mm diameter and the head loss was 20. So for the initial pipe, so if you talk about the initial pipe, everybody knows head loss will be FLQ square by 12d to the power 5. So initial pipe, let the length be L, diameter be d, friction factor is F. So head loss is given to be as 20, is FLQ square divided by 12 into d to the power 5. What is the diameter of the initial? Is 0.6. Is 0.6 raised to the power 5. So from here, can you find the value of FLQ square? 18.6624. 18.6624 is the value of FLQ square. Now, next important thing. Now the new pipe. If you talk about new pipe, so new pipe which you are going to arrange in parallel. So new pipe which you are going to arrange in parallel is going to have same friction factor, same length, but different diameter. Come on guys, but different diameter. But the initial pipe and the new pipe are connected in parallel. And what is the condition for parallel? That the head loss in the pipes in parallel has to be same. So head loss of new pipe and head loss of initial pipe should be the same. But when you connect, listen to the question carefully, question को सुनना जरूरी है. When you connect this in parallel, the loss has reduced to 10 meter. So head loss of new pipe and the initial pipe is going to be 10. So this is going to be FLQ square by 12d to the power 5 is equal to FLQ square wait. Beta, discharges are also going to change na. Discharges are also going to change. Listen. See, what was the initial discharge? Initial discharge is Q. Okay. But when you are going to arrange in parallel, see, the discharge in old pipe is, let it be Q1, and discharge in new pipe is Q2. So what is the condition for parallel arrangement? Q1 plus Q2 is equal to Q. Q1 plus Q2 is equal to Q, है ना? So this will be Q1 square, this will be Q2 square divided by 12 small d to the power 5 is also equal to 10. Now what we are going to do is, let us equate one of them. Let us equate this FL Q1 square divided by 12d to the power 5. Diameter, you know, diameter is not changing, this will remain 0.6. फैंटास्टिक प्रॉब्लम यार, अव्वल दर्जे का प्रॉब्लम है. रात को 9:30 बजे भी आप देखो, अव्वल दर्जे का प्रॉब्लम है. रात के 9:30 बजे भी आप देखो, अव्वल दर्जे का प्रॉब्लम है. माइंड ब्लोइंग है. और अभी मैं बता रहा हूं 2-3 प्रॉब्लम्स ऐसे अभी लास्ट में बचे हुए हैं. दे आर जस्ट अमेजिंग, यू कैन नॉट स्किप देम. तो ये तो हो गया जी 10 के बराबर. तो यहां से क्या आप FLQ1 स्क्वायर का वैल्यू निकाल सकते हो? बिल्कुल निकाल सकते हो. FLQ1 का स्क्वायर का वैल्यू आपका आएगा 9.3312. खत्म हो गया क्वेश्चन. 9.3312. लेट दिस बी 1, लेट दिस बी 2. दोनों को डिवाइड करो. दोनों को डिवाइड करोगे तो F और L तो सेम है, तो Q बाय Q1 का वैल्यू मिल जाएगा. Q बाय Q1 का वैल्यू मिल जाएगा और Q बाय Q1 का वैल्यू आएगा √2। ठीक है, Q बाय Q1 का वैल्यू आएगा √2। तो यहां से आपको रिलेशनशिप मिल जाएगा Q और Q1 के बीच में। सो Q1 विल बी 0.707 ऑफ Q। Q1 विल बी 0.707 ऑफ Q। एक रिलेशन मिल गया आपको, उस रिलेशन को आप यहां पर पुट कर सकते हो और Q2 को निकाल सकते हो। नहीं आया समझ? खत्म हो गया है क्वेश्चन, अब कुछ बचा नहीं है क्वेश्चन के अंदर। देखो क्या करेंगे, ये जो निकाला है इसको इसके अंदर पुट करेंगे। तो ये जो निकाला है इसको जब हम इसके अंदर पुट करेंगे तो देखो क्या आ जाएगा। सो Q1 की वैल्यू Q की फॉर्म में हमारे पास आ चुकी है। सो दिस विल बी 0.707 ऑफ 0.707 ऑफ Q1 सॉरी ऑफ Q plus Q2 is equal to Q. So can you find the value of Q2 in terms of Q? Yes. So Q2 will come out to be 0.293 of Q. 0.293 of Q. Amazing problem. Now the last step will be head losses को आप equate कर दो. So head losses क्या है हमारे पास? Head loss ये वाली equation क्या करेंगे? Q1 का स्क्वायर डिवाइडेड बाय d टू द पावर 5, दैट इज 0.6 टू द पावर 5, 0.6 टू द पावर 5 इज इक्वल टू क्या है बेटा? Q2। तो Q2 की जगह क्या लिखोगे? अभी निकाला, Q2 की जगह क्या लिखोगे? Q2 की जगह हम लिखेंगे 0.293 ऑफ Q का स्क्वायर divided by 12 into d to the power 5, and Q also you can convert in terms of Q1. Okay, so from here things will get cancelled out. Array from this relation na you can again change, okay. So from both the sides Q1 will get Q will get convert everything in terms of Q. Convert this Q1 also in terms of Q na. Here na 0.707. So in place of this you put 0.707 square of Q square. So Q square will cancel out. Only one unknown will be there, that is diameter. It will come out to be 1.977. No, wait. It will come out to be 421.8 mm. 421.8 mm. फैंटास्टिक, गजब ही ढा दिया। अरे यार ब्यूटीफुल प्रॉब्लम। बस खत्म कर रहे हैं। लास्ट 2 प्रॉब्लम्स फॉर टुडे। ओके, लास्ट 2 प्रॉब्लम्स फॉर टुडे खत्म करेंगे। उसके बाद लास्ट 2 प्रॉब्लम्स फॉर टुडे, उसके बाद खत्म करेंगे। वैसे तो प्रॉब्लम्स मेरे पास 4-5 है, बट मुझे लग रहा है आपका पेशेंस अभी लेवल टूट रहा होगा क्योंकि तोड़ना ही मेरा काम है। तोड़ना ही मेरा काम है। आसान चीजें ही करनी होती तो आज का सेशन काहे रखे होते। चलो करके दिखाओ। 2 मिनट दिया, करके दिखाओ। हालांकि क्वेश्चंस मेरे पास 4-5 है अभी बचे हुए, बट आप come on. This is again a beautiful problem. Come on. Last 1.5 minute. अच्छा प्रॉब्लम है, बहुत ही बढ़िया प्रॉब्लम है। Just look at the quality of each and every problem. Let me drink some water. If you have any doubt, Made Easy is always standing behind you. If you have any doubt, Made Easy is always standing behind you. You can always message me with your doubts on WhatsApp. You can always message me with your doubts on WhatsApp. You're always invited for asking doubts. चलिए इधर देखिए, खत्म करते हैं इसको. Look here. Look here. It's a beautiful problem on dimensional analysis. A sphere model, okay, a sphere model. So model diameter is 10 centimeter, is tested in water. So the first step is identify who is model and who is prototype. So the one sphere which we are testing in water is actually the model, okay, and the sphere model of 10 centimeter diameter is tested, okay. So diameter of the model is 10 centimeter. Next what he says, okay, the velocity in the model is 2 meter per second, What else is given? The drag force on the model. So drag force on the model is 5 Newton. Beautiful. Drag force on the model is this much. Very good, correct. Madhi Reddy, correct answer beta. Madhi Reddy, correct answer. The prototype is tested in air. So whatever testing we are doing in air is actually prototype. So prototype is tested in air, dear, okay, and prototype having a diameter of 1.5 meter. So diameter of prototype is 1.5 meter. Next is tested in air having dynamic similarity conditions, okay. Density of water is hazard, density of air is actually prototype. This is model, viscosity of water is model, of air is prototype. The drag force experienced by the prototype, take the value of CD to be itna. My dear students, so you have to find out the ratio of the drag. So drag force over the model to the drag force over the prototype. What is the formula for drag? CD of the model into half rho of the model, area of the model, V of the model ka square, divided by, अरे बाबा, you drag of the prototype, drag of the model is given, drag of the prototype you want to find out, yes or no? So drag of the model is given, drag of the prototype you want to find out, okay. So of the prototype into half rho of prototype into area of the prototype into velocity of the prototype square. See, all the things are given to you, but you need to apply the Reynolds model law, because here the viscosity will be the dominating force, na? Very good, lot of you are giving the correct answer. Anurag Chaudhary, Himanshu, Pradeep, Gautam, Rohit, Abhinav, Umda, correct answer hai sabke. Reynolds number for the model is equal to Reynolds number of the prototype. So therefore this is going to be rho of the model, V of the model, D of the model divided by mu of the model is equal to rho of the prototype, V of the prototype, and diameter of the prototype divided by viscosity of the prototype. All the values are given to you. From this particular, can you find the value of Vm by Vp? Yes. Yes, you can find the value of Vm by Vp. This will come out to be 1.977. This will come out to be 1.977. Wonderful. Now just put this Vm by Vp in this. CD of prototype and model is the same. Half and half is also gone. And how many of you realize that this area of the model is pi by 4 d square? Because it's square, na? So it is basically dm square by dp square. So drag of the model by drag over the prototype. What will be your thing? Rho of the model into diameter of the model square, Vm square, divided by rho of the prototype into diameter of the prototype square into Vp square. All the values you know, my dear students. Again a mind blowing problem. You are going to get the drag over the prototype. You are going to get the drag over the prototype as 1.320, as 1.320 Newton. Again fantastic. और बोलो वेंचुरी कराए, बाउंड्री लेयर कराए, टर्बुलेंट कराए, वोर्टेक्स कराए एंड डायनेमिक्स कराए और काइनेमैटिक्स कराए और आपको हम अभी ये भी कराए. But I will now give you hints to the problem because I have to end. So I will just give you the hints to the problem now. See, there is this container is there. In this container there is this conical thing is there. So this is a conical thing is there because there is a hole at the bottom of this container. So this cone has to avoid the leakage. So cone has to be there. So first of all, tell me whether this cone is a plane surface or curved surface. It is a curved surface. So my dear students, over this curved surface, you know the liquid above this curved surface, maximum students, what mistake they do is, in the calculation of the volume here, as it is a curved surface, horizontal force will get cancelled out. The vertical force, how to calculate vertical force? Vertical force is equal to the weight of the liquid contained by the curved surface up to the free surface. See, the angle is 60 degree. Can you find this radius? Yes, because this height is 1 meter. This height is 1 meter. Okay. So can you find this? Yes. Find the volume of the cylinder and from that volume of the cylinder subtract the volume of the cone. Will you get the weight of this liquid? Yes. Will you get the weight of this liquid? Now weight of this liquid will be rho into G, volume of the cylinder minus the volume of the cone. Volume of the cylinder minus the volume of the cone. Getting my point? Yes. Now if this is the case, now simply force balancing, how to do? See, this is the upward force and weight of this is going to, weight of the liquid is going to act in downward. So weight of liquid above cone, that you are going to find out, plus 2.5, this is again in kilonewton, is equal to 10. Now when you balance this out, you are going to find out the value of H. You are going to find out the value of H. Clear guys? Yes, 1.06. Yes, correct. H value, many of you are giving the answer 1.063. 1.063 meter is the correct answer. Last problem. Last two problems, same concept, same linear momentum equation. I have kept these problems for the last because I feel, I just feel, see, it is some kind of a forecasting and nobody knows what is going to come into the paper, but still I feel that the linear momentum equation might come in the paper, Read the problem, let us not hurry, let us complete in a mind-boggling manner. Just read the problem, it's a beautiful problem. Just read the problem. So there is this pipe is there from 1 to 3. Let me explain to you. There is this pipe is there from 1 to 3 and from this pipe there is a nozzle which is attached up to 0.2. The diameter of this pipe is given to be as 10 centimeter and diameter of the nozzle is given to be as 6 centimeter. That fellow is asked, other few things are also given. Pressure at section 1 is given to you. And velocity at the nozzle is given to be as 6 meter per second. and head loss, head loss is between 3 and 2. Between 3 and 2 there is a head loss is there, but between, clearly has said that the head loss between 1 and 3 is negligible. What he is asking? He is asking the x component of force over the bolt. क्या प्रॉब्लम है? और बोलो, और बोलो क्या ख्वाहिश है, और बोलो क्या ख्वाहिश है, क्या प्रॉब्लम है? करो करो, ट्राई करो. क्या शानदार. आज सही बताऊं, पाठक सर ने अपना दिल खोल दिया. GTQ1, GTQ2, GTQ3, हर GTQ पिछले GTQ से बेहतर, हर GTQ पिछले GTQ से बेहतर. चलो करें. देखो, फोर्स निकालने के लिए आपको वही अपना मोमेंटम, लीनियर मोमेंटम इक्वेशन लगाना पड़ेगा, लेकिन उससे पहले भाई यहाँ का प्रेशर वगैरह चाहिए होगा ना, P3 वगैरह चाहिए होगा, उसके लिए बर्नौली यूज करेंगे. ठीक है. सो ऐसा करते हैं कि 1 और 2 के बीच में कॉन्टिन्यूटी लगाते हैं. मैं आपको हिंट्स दूंगा और आंसर बताऊंगा. ठीक है. 1 और 2 के बीच में कॉन्टिन्यूटी लगाते हैं. A1 V1 इज इक्वल टू A2 V2. हाउ मेनी ऑफ यू रियलाइज के क्वेश्चन में V2 दे रखा है 6 मीटर पर सेकेंड. सो A1 विल बी पाई बाय 4 इंटू 10 सेंटीमीटर ना, सो 0.1 का स्क्वायर इंटू V1. So V1 you need to find out, and this is pi by 4 into diameter का square is 6 centimeter is 0.06 का square multiplied by V2, multiplied by V2. V2 is 6. V2 is 6. So from here can you calculate the value of V1? Tell me in the comment box. I am waiting for your answers. Tell me in the comment box what is the value of V2. Tell me in the comment box what is the value of V1. 2.16 meter per second. 2.16 meter per second is the value of V1. ठीक है. अगर ये निकल गया तो let us apply Bernoulli's equation between 1 and 3. Let us apply Bernoulli's equation between 1 and 3. Let us apply the Bernoulli's equation between 1 and 3. So when you are going to apply Bernoulli's equation, this will be P1 by W plus V1 का square by 2G plus Z1 is equal to P2 by W plus V2 square by 2G plus Z2. Okay, and between 1 and 3 there is no head loss. Actually I want, we are applying between 3 na, so this is not 2. Just a moment. This is not 2. This is not 2. This is 3. We are solving bit. So 3 is this. 3 is this, mere lal. 3 is this. Okay. So this is P3 by W, V3 and Z3. My dear students, which if you are applying between 1 and 3, which one will you take reference? This will be reference. So Z1 will be equal to 0 and this will be Z3. This will be Z3 and there is no loss. V3 and V1 will be same. Why? Same pipe na, same diameter. So that will get cancelled out. V1 and V3 same pipe, same diameter. So this will get cancelled out. Okay. So P1 is given to you in the problem. What is the value of P1? 1.5 into 10 to the power 5. So this is 1.5 into 10 to the power. Nice problem. 10 to the power 5 divided by W. Which fluid is flowing beta? Water, if I am not wrong. Yes, water is there. So divided by W. W for water is 9810 and Z1 is 0 because we have taken as reference, is equal to P3 by 9810 plus Z3. The value of Z3 is 10. So from here, can you get the value of P3? Yes. P3 will be 30312.9. 30312.9 पास्कल. मजा आ गया. यही हमें चाहिए था. Now we can solve. How we can find the force? चलो. Now this is the beauty na. How we can find the force? Let us take a control volume. 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 Okay, just wait a minute. I have committed a small mistake here. The value of P3 is not this. Just a moment. The value of P, extremely sorry beta, change. The value of P3 is not this. This is the value of P2. Okay, P3 will come out to be 51900. 51900 Pascal approximately. 51900 Pascal approximately. Okay. Yes, you guys are correct. But wait. See, this is not discharging to the atmosphere. Can you see? Nowhere in the question it is mentioned that it is discharging to the atmosphere. So this is not discharging to the atmosphere. So there will be some value of P2. How to find the value of P2? You should apply Bernoulli between 3 and 2. What a mind-blowing problem. What a mind-blowing problem. 3 and 2 you should apply Bernoulli now. So this will be P3 by W plus V3 का square by 2G plus Z3 is equal to P2 by W plus V2 का square by 2G plus Z2 plus head loss. Can you see there is a head loss between 3 and 2? It is given in the problem. यार इसे कहते हैं क्वेश्चन. इसे कहते हैं क्वेश्चन. इसे सही में कहते हैं क्वेश्चन. अब देखो पूरा धुआं निकाल देगा. इसे कहते हैं क्वेश्चन. ये 0.6 है. 2 और 3 सेम हॉरिजॉन्टल लेवल पे है. ठीक है. V3 और V2 तो आपको पता ही है और V3 V1 के बराबर होगा. अरे V1 और V3 सेम डायमीटर ना, तो V3 V1 के बराबर होगा. P3 आपको पता है. क्या यहां से P2 निकल जाएगा? यस सर. सो P2 विल बी 30312.9. 30312.9 Pascal will be the value of P2. Will be the value of P2. Chalo, how to find the force? So we have taken this control volume. Over this control volume, the pressure force will be P3A3 from here. The pressure force from here will be P2A2. And reaction force, because it will only be in x direction. So reaction force I am taking Fx something like this. So what is the linear momentum equation? Linear momentum equation is very simple. Summation of forces in a particular direction is m dot into velocity out of the control volume minus m dot into velocity into the control volume. This is the linear momentum equation. Let us apply here. So P3A3 is towards the right, we will take positive, minus P2A2 plus Fx, m dot is common, V out is V2. अरे बाबा V out is V2 बेटा, and V2 is 6, minus V in. So therefore V out is 6 minus V in. V in is V3. We have already found V3 here, 2.16. So this is 2.16. M dot is rho into Q. Very simply, M dot is rho into Q. My dear students, when you are going to calculate from here, anyone with the answer? What will be Fx? See, P3 you know, A3 you know, P2 you know, A2 you know, M dot you know, 6 you know, this you know, everything you know. The value of Fx will be 256.77 Newton. 77 Newton. मजा आ गया जी. और बोलो. क्या ख्वाहिश है. आज तो लग रहा है हर ख्वाहिश पूरी कर दी जाएगी. आज तो लग रहा है हर ख्वाहिश पूरी कर दी जाएगी. देखियो जी ऐसा सवाल, क्या क्वेश्चन है यार. एंड डोंट थिंक ये गेट रेलेवेंट क्वेश्चन है. ये आपको बहुत कुछ सिखा रहा है. चलो, ये एक क्वेश्चन मैंने प्लान किया था, ये आपका होमवर्क है. ये क्वेश्चन आपका क्या है? होमवर्क है प्यारे बच्चों, ठीक है। मैं आंसर बता देता हूं आपको इसका, ताकि आप घर पे चेक कर सकें, ताकि आप घर पे इसको चेक कर सकें। मैं आपको आंसर बता देता हूं इसका। इसका आंसर, मैं इसका आंसर आपको बताता हूं जब तक आप ये वाला सॉल्व करो। ये वाला हम लोग अभी सॉल्व, मतलब मैं हिंट दूंगा इसकी, मैं हिंट दूंगा इसकी। इस वाले का आंसर आएगा, इस वाले का आंसर आएगा 11.5 किलो न्यूटन। 11.5 किलो न्यूटन। यू बेंड, यू बेंड है, वही करना है। देखो क्या करेंगे, यहां पर एक सेक्शन लेंगे, यहां पर लिखेंगे P1A1, बस साइन का ध्यान रखना। दिस विल बी रिएक्शन फोर्स Fx, यहां पर कंट्रोल वॉल्यूम ये लेंगे, मैं आपको थोड़ा हिंट कर देता हूं, कंट्रोल वॉल्यूम ये लेंगे, और यहां से ये एटमॉस्फेयर है, दिस इज ओपन टू द एटमॉस्फेयर। सो P2A2 हम लोग गेज के टर्म्स में सॉल्व करते हैं, इसलिए P2A2 जीरो हो जाएगा, ठीक है। यहां पर इनलेट वेलोसिटी V1 और यहां से एग्जिट वेलोसिटी V2। बेटा साइन का ध्यान रखना है, टुवर्ड्स द राइट इज x पॉजिटिव, टुवर्ड अपवर्ड इज पॉजिटिव। आर यू गेटिंग माय पॉइंट? यस सर, वी आर गेटिंग ईच एंड एवरी पॉइंट ऑफ व्यू सर। तो इसको सॉल्व करेंगे, वही लगाएंगे यहां पर थोड़ा सा आसान है बल्कि, बट दिस इज टुवर्ड्स द लेफ्ट, सो माइनस P1A1 प्लस Fx विल बी इक्वल टू m डॉट 2 V2, है ना। एग्जिट की बात चल रही है, बट एग्जिट तो राइट की तरफ है तो प्लस लिया, है ना। एंड दिस विल बी m डॉट 1, m डॉट 1 इज द एंट्री बट इट इज टुवर्ड्स द लेफ्ट, सो माइनस V1 लेंगे। मैंने देखो इसमें भी आपको बता दिया, और क्या लोगे, इसमें भी मैंने आपको बता दिया क्या होगा, ठीक है। इसको सॉल्व कर लेना, Fx आ जाएगा 11.5 किलो न्यूटन। मैंने यहां तक गाइड कर दिया आपको। चलो बेटा, लास्ट क्वेश्चन, लास्ट क्वेश्चन, लास्ट क्वेश्चन। इसकी भी हिंट दूंगा और आंसर बताऊंगा, इसकी भी हिंट दूंगा और आंसर बताऊंगा, ठीक है। आपको फाइंड करना है गेज प्रेशर एट सेक्शन 1 और दूसरा मैग्नीट्यूड ऑफ फोर्स ओवर दिस। मैग्नीट्यूड, सिंगल एंट्री मल्टीपल एग्जिट, सिंगल एंट्री मल्टीपल एग्जिट। हाँ भाई, कैसे करेंगे बेटा? ये क्या कहते हैं, गेज प्रेशर निकालने के लिए तो बर्नौली का सिद्धांत यूज करेंगे, बिटवीन 1 और 2 और एनीथिंग लाइक दैट। बेटा 1 की बहुत सारी चीजें तुम्हें दे रखी हैं, है ना। एक तो सबसे पहली बात तो आपको 1 का एरिया दे रखा है, सो A1 is given to be as 0.2 मीटर स्क्वायर एंड वेलोसिटी एट 1 is given to be as 3 मीटर स्क्वायर। मैं आपको हिंट कर देता हूं, क्या तुम डिस्चार्ज निकाल सकते हो? यहां से 0.6 आ गया, 0.6 मीटर क्यूब पर सेकंड आ गया। अच्छा एक और बात देखो, ये एरिया अगर A1 है, ये एरिया अगर A1 है तो A2 और A3 बराबर है, A2 इज इक्वल टू A3 है, और A2 इज इक्वल टू A3 है, तो जितना डिस्चार्ज यहां से आ रहा है क्या वो इक्वली डिस्ट्रीब्यूट हो जाएगा? मैं आपको हिंट दे रहा हूं, क्या वो इक्वली डिस्ट्रीब्यूट हो जाएगा? बिल्कुल वो इक्वली डिस्ट्रीब्यूट हो जाएगा, कोई माइका लाल नहीं रोक सकता जी, बिल्कुल इक्वली डिस्ट्रीब्यूट हो जाएगा। सो अगर वो इक्वली डिस्ट्रीब्यूट हो जाएगा तो सारी चीजें आपके पास होंगी, एंड दिस इज डिस्चार्जिंग टू एटमॉस्फेयर, दिस इज डिस्चार्जिंग टू एटमॉस्फेयर। और P1 आपको दे रखा है क्या? अच्छा P1 तो आपको निकालना ही है, P1 तो आपको निकालना ही है, खत्म हो गया क्वेश्चन। अप्लाई बर्नौली बिटवीन 1 and 2, अप्लाइंग बर्नौलीज इक्वेशन बिटवीन 1 and 2। सो 1 और 2 के बीच में बर्नौली अप्लाई करेंगे, 1 और 2 के बीच में बर्नौली अप्लाई करेंगे, ठीक है। सो दिस इज P1 बाई W प्लस V1 का स्क्वायर बाई 2G प्लस Z1 इज इक्वल टू P2 बाई W प्लस V2 का स्क्वायर बाई 2G प्लस Z2। देखो हाइट्स का कुछ नहीं दे रखा है तो ये तो हटाओ, P2 बाई W एटमॉस्फेरिक तो ये भी हटाओ, है। और देखो V1 और V2 तुम्हें यहां देखो, Q1 तुम्हें मिल चुका है, Q1 तुम्हें मिल चुका है, और क्या तुम्हें समझ में आता है कि Q2 प्लस Q3 ही Q1 होगा, Q2 प्लस Q3 ही Q1 होगा, और ये होगा 2 टाइम्स ऑफ Q2 इज इक्वल टू Q1। तो क्या यहां से Q2 निकल सकता है? विल बी Q1/2, दैट इज 0.3। अगर तुम्हें Q2 मिल गया, अगर तुम्हें Q2 मिल गया, Q2 कैन बी रिटन एज A2 इंटू V2, कैन बी रिटन एज A2 इंटू V2, है ना बच्चे? यस सर। ऑफ कोर्स ही बात है, वेलोसिटी डबल हो जाएगी ना, वेलोसिटी डबल हो जाएगी, सो V2 विल कम आउट टू बी 6 मीटर पर सेकेंड एंड V3 will also be same because it is a symmetric fork, that will again be 6 meter per second, that will again be 6 meter per second। अरे जिंदा हो तुम लोग, आओ करते हैं। तो भैया आपको V1 पता है 6 है, V2 आपको पता है 3 है, सॉरी V1 आपको पता है कितना है, 3 है, और V2 आपको पता है 6 है। तो क्या यहां से आपका P1 निकल जाएगा? बिल्कुल निकल जाएगा, मैं आंसर बता देता हूं। P1 आपका आएगा 13.5। सो आंसर इज बी, बॉम्बे। किसी ने दिया है क्या? श्रीमणि, श्रीमणि करेक्ट आंसर, श्रीमणि करेक्ट आंसर। हाईली इंप्रेस बेटा, हाईली इंप्रेस बेटा। सो दिस विल बी 13.5 किलो पास्कल आएगा ये, 13.5 किलो पास्कल। गजब। अभी भी खत्म नहीं हुआ है साथियों, आखिर मेन सवाल तो बचा है। मैग्नीट्यूड ऑफ फोर्स इन किलो न्यूटन रिक्वायर्ड टू होल्ड द पाइप इन प्लेस। मैं सिर्फ आपको हिंट दे रहा हूं। सो हम लोग अपना कंट्रोल वॉल्यूम कैसा लेंगे? कंट्रोल वॉल्यूम हम कुछ इस तरीके से लेंगे, कंट्रोल वॉल्यूम हम लोग कुछ इस तरीके से लेंगे, ठीक है। कंट्रोल वॉल्यूम इस तरीके से लिया तो ये तो हो जाएगा भाई, यहां से लगने वाला फोर्स होगा P1A1, यहां से लगेगा P2A2, लेकिन ये डिस्चार्जिंग टू द एटमॉस्फेयर है और हम लोग गेज के टर्म्स में सॉल्व करते हैं, तो ये तो गया। फालतू करने का क्या, जल्दी जल्दी सॉल्व करेंगे ना, गेट का पेपर है। P3A3 ये भी गया, बिकॉज P3 एटमॉस्फेरिक होगा, ठीक है। परंतु यहां पर जो ये एग्जिट कर रहा होगा V2, देखना जरा, V2 है ना, तो V2 के कंपोनेंट्स होंगे, V2 के कंपोनेंट्स होंगे, ठीक है। सो V2 के कंपोनेंट्स होंगे तो ये होगा V2 cos 60 डिग्री, क्योंकि लीनियर मोमेंटम इक्वेशन या तो x में अप्लाई करोगे या तो y में अप्लाई करोगे, एंड दिस विल बी V2 sin 60 डिग्री। जबकि यहां पर ये देखो, ये है कितना, V3, सो V3 का V3 cos 60 डिग्री, V3 cos 60 डिग्री, और यहां पर ये है V3 sin 60 डिग्री। अरे ठीक है, यस सर, वंडरफुल, बहुत उम्दा, आ जाओ, खत्म हो गया क्वेश्चन। सो ये सब आपने कर लिया। और रिएक्शन फोर्सेस कैसे दिखाओगे, बोलो मेरे लाल, रिएक्शन फोर्सेस कैसे दिखाओगे? Fx और Fy। मेरे को पहले ही यहां समझ में आ रहा है Fy तो निकल जाएगा। तो क्या करेंगे भाई, समेशन ऑफ फोर्स इन हॉरिजॉन्टल डायरेक्शन और x will be, बताओ, m डॉट आउट, सो देयरफॉर दैट विल बी आउट। कौन कौन हो रहा है भाई? m डॉट 2 इंटू V2 cos 60 डिग्री, ये एक तो ये आउट हो रहा है, प्लस m डॉट 3 इंटू वेलोसिटी, सो मोमेंटम आउट इज, इसका भी राइट की तरफ है, सो V3 cos 60 डिग्री, ठीक है बच्चे, ये हो गया। माइनस इन कितना है, m डॉट 1 इंटू V1, m डॉट 1 इंटू V1। सो रेट ऑफ मोमेंटम आउट माइनस रेट ऑफ मोमेंटम इन इज द फोर्स इन x डायरेक्शन। सो फोर्स इन x डायरेक्शन क्या होगा, P1A1 प्लस Fx, क्योंकि बेटा P3A3 और P2A2 के तो कंपोनेंट्स करने का कोई फायदा ही नहीं है, कोई फायदा ही नहीं है, ठीक है। और तुम्हें पता है ये सब जो है, ये राइट हैंड साइड जब तुम कैलकुलेट करोगे, अकॉर्डिंग टू मी ये जीरो हो जाएगा। जब आप ये राइट हैंड साइड कैलकुलेट करोगे तो ये जीरो हो जाएगा, तो आपके Fx की वैल्यू आ जाएगी, आपके Fx की वैल्यू आ जाएगी 2.7 किलो न्यूटन, 2.7 किलो न्यूटन, हाँ, ये आ जाएगा आपका फोर्स। अच्छा, वर्टिकल डायरेक्शन में करने का कोई फायदा नहीं है। क्यों फायदा नहीं है? देखो, वर्टिकल डायरेक्शन में मोमेंटम इन तो है ही नहीं, और मोमेंटम आउट जो है एक ऊपर की तरफ है और एक नीचे की तरफ है, वो कैंसिल कर देंगे एक दूसरे को, तो एफ वाई का वैल्यू क्या आएगा? 0। अगर आप निकालोगे भी तो एफ वाई का वैल्यू क्या आएगा? 0 आएगा। तो अपने पास क्या आंसर आ गया? 2.7। आंसर इज ए, आगरा। 2.7 आंसर इज ए, आगरा। 2.7 आंसर इज ए, आगरा। गजब। 2.7 आंसर इज ए, आगरा। हाँ भाई बच्चों, जल्दी से जल्दी कमेंट बॉक्स में खत्म। अब और कुछ नहीं करवा रहा हूं, अब और कुछ नहीं करवा रहा हूं, बहुत कुछ आज डिस्कशन कर लिया है। अब देखो पिछले लास्ट 4 घंटे से आई अप्रिशिएट उन बच्चों को जो अभी तक मेरे साथ लगे हुए हैं। बट आप देखो, विदाउट एनी ब्रेक, with full of energy, just look at the conceptual clarity of this GTQ. आप तोलिए उसको, just look at the conceptual clarity of this GTQ. हमने नॉर्मल क्वेश्चन से शुरू किया जिससे हमारा पूरा सब्जेक्ट रिवीजन हुआ, और अंत तक जाते जाते आप देखो कितने ब्यूटीफुल सेट ऑफ क्वेश्चंस मैंने आपको करवा दिए हैं। So those of you who are my regular batch students, share your feelings with me, share your feelings with me, because तुम लोगों के लिए बहुत मेहनत किया, and I hope के मजा आया। I wish you all the very best for your GATE 2023 पेपर। ठीक है, अपने आप को कूल रखो, काम रखो, कंपोज रखो। तुम्हें सब चीजें आती हैं, अप्लाई करना भी आता है। ठीक है, लास्ट मिनट में पैनिक करने की कोई आवश्यकता नहीं है। जस्ट बी हैप्पी, अपने तैयारी पे कॉन्फिडेंस रखो। ठीक है, बाकी आगे मिलते रहेंगे ऐसे ही करके। चलो, so on that note, this is Varun Pathak sir signing off for today. Jai Hind. Namaskar everyone.